Dr. Gold in the lab, Twitch stream glowing, formulas flashing, minds wide, knowledge flowing, equations on the board, numbers never sleep, teaching math and physics while them haters count sheep. Actual education, tune in and get schooled, flipping textbooks, breaking all the rules, from Newton to Einstein, concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex, quantum theories on deck, breaking all the specs, relativity theories, worlds getting small, grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep, grazing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold, brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice.
What's up, everybody? All right, let's see. It is Tuesday. Kind of fun, right? All right. What's up, Machka? What's up, Gladiator? How'd your test go? Didn't you have a test, Gladiator? Sorry, let me get my chat working here. Turn that off. No, that's not it. Where is Donde está mi chat? Wait, what the hell? Yeah, social stream. Yeah, that should be working.
Yo.
What's up, Nick? How's life, dude?
Yo, should I stream my
What do you got for us?
surround?
What do you got for us?
Oh. Bro, I said that and right away one of my roomies like, I'm gonna pull my dick out.
Don't do that. They're children.
Yo.
They're children.
There's children here. Fuck. Right here.
This is... One sec. Let's go see. One second.
Oh,
Let me do this. One sec. Oh, I got too many things open. There we go. This is your cadet room?
Yeah.
Oh.
I'm a fucking bar. Hold up. I need some fucking food open.
Dude, this looks like a prison, honestly. What?
It is a fucking prison.
It looks like kind of a prison. How long are you in prison for?
For 8 weeks right now.
Oh, okay. That's not too bad. Wow, Nick in the
My,
flesh, dude. Face reveal, dude. I don't think I've ever
First
actually
time
seen your
in,
face. I've never seen your face, Nick,
5,
in
6
like
years, I think.
the 6 years I've known you.
Yep.
What is the shirt? What does that say?
That's our shit. That's our names and shit.
Oh yeah, Nick Kroner. Yeah, I know your last name,
Yeah.
Kroner. Nice.
Yeah.
LeClaire. Cool. Wow.
Yeah,
Yeah, you guys got like the classic Yeah, that's
Bro, I don't
funny.
even want to show my bed and shit. It's so fucking messy.
So how many weeks are you in?
Anyways.
How many weekends are you in right now?
This is my 8th week.
Nice. Okay.
Yeah.
So this is the last week then.
Yeah. We're gonna
Sick.
graduate on Friday.
Wow.
Yeah.
Dude, I would if I was on the East Coast, I'd come to your graduation, dude. I think it'd be super funny. It'd be like it'd be a whole like oh, what's up? We got rated by Zach. What's up, Zach?
Do I have what you call it? I think I'm gonna have like it online or something. I have a flash drive and shit, so I might.
Oh, okay. Yeah, are they gonna stream your graduation?
Probably or something.
Oh, send us a
Record
fucking
it.
link, dude. I'll watch it. I'll go watch it. You've been E to the 2I rated. Welcome, Raiders.
I
Welcome.
have an email already.
Oh, well, forward it to me, dude. I want to see it. I need my chat to work. Dude, what did they do to my chat? Where is it? Is it stream labels? Social stream ninja. One sec.
Forward. What's your email, by the way?
geo@actual.education. There it is. It's under
Include
OBS.
attached to Geo. Do you have an I in Geo?
Yes, GIO. GIO at, and then it's actual.education. Okay, is my chat working finally?
Send.
Nice.
I don't know if this is a link or I don't know what the fuck it is, but yeah.
We'll check it out. Nice. 1K says, my friend got kicked out of cadets. Oh dear. Why did your friend get kicked out of cadets? How? That's not good.
If I can make it, you can too, bro.
Yeah. Nick can make it. You can make it, dude. Yes. That's how this works. GO would be cooler than GIO. Yeah. You know, we used to always joke with like that like my nickname was like geometry, like geometry.
Bro.
1K, he was spamming the hard R. God damn it. Nick went through kind of a phase of that. I'm glad we outgrew that phase. That was good.
Hopefully.
Surprise, motherfucker.
Hopefully.
It still pops up here and there, no.
Oh, I know. Anyways, okay. Cool. Welcome everyone. Welcome Raiders. Today is Tuesday. Right? Did I get that right? Today's Tuesday? Yeah, chat's working now. Yeah, sorry. I had to update my whole thing and then it always just breaks things. Streaming, you would think it would just be like set it, forget it. It's great. Things work. Very much not so. Everything's always updating, everything's constantly breaking, and it's just like you're like trying to keep the cats together from like, messing up too much. Okay, cool. All right. Anyways, awesome. Yeah. Some announcements. Yeah, great announcements. Let's see. This will be the last week of streaming for probably the next week and a half because I'm going to Japan next week for like 9 days. So make sure if you got any questions, math and science, get them in this week. We're gonna do a lot of fun stuff to kind of like celebrate. What's up, Daria? Oh wait, Daria. Wait, that's not Daria, dude. That's Jamarcus. What's up, Jamarcus? But Friday we got a game of the week. So if you want to vote for what game we play, please do it in our Discord. It's under the game of the week vote here, poll of the week. There we go. And currently, looks like chess is winning. So you can vote for Fortnite, Rocket League, chess, Fall Guys, Marbles on the Stream, or if you want to suggest something else, other. And then we'll spin on Thursday for what game that is. We're going to play it on Friday. That'll be at 6 p.m. Pacific. Again, you can always figure out when all the cool events are happening in our Discord and also on the streams and everyone else's streams if you go here to the streaming schedule. Nice. So Zach was just streaming. Awesome. Did I shout you out, Zach? Sorry, I was in the middle of fixing all my chat stuff. Okay. There we go. Shout out to Zach. Zach's great. Thank you. Yes, I'm going to have fun. Yeah, I've been to Japan before. This is my first time back in like 10 years, actually. Yeah, last time I was in Japan was in 2016, quite a while ago. Dario says, we finally got to the limit definition of a derivative. Congrats. Yes, it's Noyce's birthday tomorrow, by the way. or I think his birthday's like kind of today technically because it's in UK time. Yeah. Japan giveaway. Yeah, wouldn't that be it? That would be dope. Yeah, here. This was me in Japan back in 2016. This is a young Dr. Gold. Youngish. I think I was 26. Yeah. No, sorry, 2015. Sorry. Oh, I was 25. Yeah, there we go. That's me in Japan. So, yeah, Japan's great. It's cool country. I 100% recommend people to go travel more in their life, especially when you get into your 20s. It's like the one unique point of you don't really have that many responsibilities and you have autonomy. Like, you can go do things without your parents' permission. So 100% use your 20s, go travel. It's some piece of advice that someone older than me gave to me when I was in my 20s, and I'm very glad I took his advice. So that's my advice to you guys. Yeah, 2016, what a time.
Bing bang.
Yeah, 2016 was crazy. Yeah. So, yeah, cool. Also, we have a Golden Hour podcast on Saturday. That's going to be with Ramton, and he's going to be going over... We have 2 contenders for topics. It's either going to be over planetary motion and, like, the Coriolis force and, like, transfer orbits and stuff, like cool space shit, or we're going to do electromagnetics and applications to modern day things. So if you want to come check that out, that'll be on Saturday. That's starting at 1 o'clock Pacific. We'll give out gift cards to whatever best questions. So yeah, we had a 2016 day at school to dress up like then, dude. That's what? No, 2016 wasn't that long ago. It's not like the fucking 70s where we're like, oh, let's dress like the 70s. Dress up like 2016? I don't even know what dress up like 2016 means. And yes, limit definition is tedious. Okay. Fidget spinners. Okay, I guess that was a thing. Yeah, okay. You were 8 back then. Yeah. What a time to be alive. Alright. That being said, I know we got a lot of questions in the queue right now, so let's start off the stream, help you guys out with some math and science, and let's kick some stuff off. Here we go. Alright, welcome everyone to Actual Education Office Hours. My name's Dr. Gold. This is a stream that helps you out with math and science homework.
Nice.
All sorts of fun stuff. The Great Meme Reset. Yeah, it actually was the Great Meme War. Have you seen those hats where they say, like, Meme War veteran? I low-key want to get one of these hats. Yeah. Because 2016 was, like, the Great Meme War. And as we're now finding out from the Epstein files, it was kind of generated by Jeffrey Epstein himself, actually. Who would know that 4chan and Poll and everything was created by an Israeli Mossad agent? Yeah. Wasn't on my bingo card. Liar. All good questions except breasticles. Okay, here we go. All right, so how this works, for those of you that are new and just rating us, we go through all sorts of whatever math, science questions that you guys, the audience, ask. We do them here live on the stream. If you want to submit a question to our stream, the best way to do that is to use our handy-dandy vibe-coded website that Zach loves. And the website link for that is www.actualofficehours.com. You can put your username in here. You can drag in a screenshot and hit upload. Once you hit upload, it'll show up here on the queue. And so here's the live queue. And how this works, because we don't go strictly in order of who submitted first, we like to gamble. So if you submit your question early on, it accumulates more votes, and then if you ever want your question to kind of get bumped up, you can click on this upvote button. But every question can only be upvoted once every 3 minutes. It is the most secure website ever. Yeah. And if you ever want to see what someone else's question is, you can just click on their username here. Like, for instance, just click on breasticles. There you go. Wow, Fourier transforms. This one looks fun. Okay, cool. All right, so that's how this works. That being said, oh wow, my chat's actually working now on TikTok. Holy shit! Oh, dude, TikTok, my beloved. Why do you hurt me so, TikTok? All right, 1 second. There we go. Let me fix that. My TikTok chat wasn't working for the last like 4 days, and now all of a sudden it wants to work. Great. Okay. Let's go live there. Okay, nice. Yeah, good to see you, Nick. Tell Ash to get back on the stream and bring Kev. Okay, we're gonna go choose a winner. So let's go gambling.
Let's go gambling!
And we'll see. What do we got? First question goes to Gladiator. Which you did have the best chance at winning. 32.8% chance. Nice. Okay, let's see what Gladiator's question is. Something about functions. Unfair. It's all rigged unless I win. Rigged. Yeah. Okay. This is, and I think this is a rational equation actually. It says, okay, given the function ax plus b over cx plus d, where x does not equal negative d over c, and a, b, c, and d are non-zero constants, what relationship needs to exist between a, b, c, and d such that each tangent line to the function has a positive has a positive slope? Wow, this is actually kind of fun actually. Okay, so slopes of tangent lines. Just always remember this, like the slope of a tangent line is always like the derivative of the function. I swear, if you just like remember this fact and just anytime you see the word tangent line or slope, just be like, no, it's the derivative. It's the derivative of the function. So the slope of the tangent of the line tangent to f of x is the same as the derivative of f of x, and then that's like at x. So yeah, and we want it to be positive. So f prime of x, let's calculate what f prime of x would be. So if f of x is equal to ax plus b over cx plus d, and we want to take a derivative, this is going to end up being a quotient rule. I hate the quotient rule. It's like my least favorite derivative rule. And so how that works, right? You take the derivative of the top. So the derivative of the top here, a, b, c, and d are constants. So unless they have like an x attached to it, the derivative of those things are 0. All my homies hate the quotient rule. Yeah, dude. No one likes the quotient rule. All right, so the derivative of the top part is just going to be a. And then that's times the bottom, which would be cx plus d. And then, math trade is impressive. What's the math trade? Math stream, you mean? All right, and then derivative of the bottom, which that would just be c, and then just times the top. So ax plus b. And then all of this is now divided by the bottom squared. So this is all divided by cx plus b squared. I thought this was going to be number theory, not calculus. I think it's definitely calculus. Also, because I think Gladiator's in a calculus class. This is where context comes in handy. Yes, quotient rule, exactly. Okay. And then we need this to be positive, right? So we need this whole thing here, the derivative, to be greater than 0. Okay. Cool thing here is I don't think I give a fuck about cx plus d, right? I can... Yeah. Oh, yes, you're right. Technically, it's cx plus d squared. But I don't think I care about the bottom anyways, right? Because the only restriction would be if the bottom somehow equaled 0. But what we specifically were told right here is that x does not equal negative d over c. Because watch what happens if it did equal negative d over c. If it was negative d over c, you'd have c negative d over c plus d. This would cancel. And then you get negative d plus d, which would be 0.
No.
And that would be bad. So the one case where there's a discontinuity is already excluded from what x is. Yeah. yeah, so we can get rid of this because we can just multiply this on both sides, right? Zeros just eat things. So that goes away. All right, now we're left with, let's like distribute in. So I have ACX plus AD minus ACX minus BC has to be greater than 0, right? Oh yeah, it is. It kind of looks like a determinant, right? Yeah, look at this. So ACX, and look, minus ACX. So these things are going to cancel. That's beautiful. Love that. And then, yeah, okay, we have AD minus BC is greater than 0. AD minus BC is greater than 0. Cool. Okay, so what relationship needs to exist between A, B, C, and D? Oh, I guess you could just say this, right? A times D has to be greater than B times C. I think that's it. Yeah? Cool. Dubs. It does kind of look like a determinant of sorts. Nice. Okay, good job there, Gladiator. W solution. W question. What is a determinant? So yeah, what Jeff's kind of saying. So if you had a quadratic equation, so let's say you just had a quadratic. Apparently everyone's taking linear algebra this semester. Yeah, it's that time of the year. If you have ax squared plus bx plus c, and you're solving this for equal to 0. Oh, that determinant. Okay, yeah, let's do that one. Sorry, that's what I meant. Yeah, sorry, this one. A, B, C, D. Yes, this determinant. I started thinking quadratic determinant. Yes, okay. If you have a 2x2 matrix and you want to find the determinant of this matrix, that's equal to AD minus BC. Yeah, like that. The determinant, I don't know, intuitively, how do we think of a determinant? I think it's kind of like the magnitude of the matrix almost, a little bit, right? It's like how big the matrix is, ish. What's it an indicator of? Yeah. I know it gets used in a lot of stuff, right? Like if you're trying to find the inverse of this matrix, you end up doing like 1 over the determinant, and then you like, I don't know, you flipsy some things. We need a linear algebra ace to your stat. Maybe Breasticles is coming in with us. Cool. Yeah, come up. You're good.
So like use a determinant a lot. Life got crazy when it popped up in PDEs.
Life got crazy when determinants of matrices popped up in PDEs.
No, not of matrices, like literal like quadratic determinants pop up in PDEs to define them. But usually it's kind of like, it's almost like a scaling factor, right? When you look at a matrix as a linear transformation, you can use the determinant to figure like how it scales under that transformation.
Like how much it scales by, I guess.
Yeah, and that helps you tell like different properties of it.
Yeah. Matrices are used for
like
systems of equations. That's true too. Yeah.
Yeah, and I want to say it's a determinant of like the Jacobian matrix, for example. I want to say it was a Jacobian, but Calc 3 was a
Jacobians get used a lot for coordinate transformations, right?
Coordinate transformations.
Yeah, I remember that one.
And so like for that, you would take the determinant of that, and that helps you with your what's it called, your coordinate transformation.
Yeah, when you're going from like linear to from Cartesian to like spherical or something. Yeah,
even sometimes we just define it as like our own,
or we come up with our own coordinate transform
system. Yeah.
Yes. Yeah. Yeah, exactly. When dx dy goes to r dr d theta, I think that's like an example of it. This is a cool one. Yeah. My teacher's briefly going to go over matrices after calc. Yeah, matrices are cool. I mean, they're especially useful in lower math classes for solving systems of equations, especially stuff that's like more than like 2 equations and 2 unknowns. Like if it's 4 equations, 4 unknowns, matrices are super dope. And then what Breasticles was saying is, yeah, when you get into calculus 3, which is like multivariable calculus, a lot of times you have to transform the variables or like the coordinate system with what you're integrating or deriving or whatever. And the easy way to figure out how you move between coordinate systems is to use matrices. They're great for doing that. Jacobians, one of my favorite topics.
Bing, bing, bang.
Ronald says, my last semester I'm going to have statics and circuits, which will be harder. I can help you with circuits.
Good job.
Statics, I tend to think is just kind of bullshit engineering physics.
Yeah, pretty much.
They call moments instead of torque, right? Yeah, it's just weird.
Yeah, and instead of using kilograms, they use slugs.
Slugs?
Yeah, I remember in ODE we were solving problems, and for some reason my teacher didn't want to use SI units, and they were doing it all in slugs, and I like
slugs.
Yeah, I couldn't follow any of that.
That's all dumb.
It was horrible.
Nice. Okay, good question there, Gladiator. Here, I'm going to give you a point. And it's going to go into our Discord. So if anyone ever wants to see the solutions to things we do, we post them in our Discord channel right here. And so also there's like a cute little timestamp that shows the recording of the live stream and then like exactly what time we did the question at, so you can always go back and watch it. We got a test Brickles now. Someone's mocking you, Breasticles. There's a test Brickles now in the
Someone
in the
is,
queue.
but I think they're just upset that I have a cooler name than them.
That you're mogging them with the name.
Disqualified.
Okay. Let's go choose the next winner for what question we're gonna do. Okay, here we go.
Let's go gambling!
Ooh, what are we gonna get? Who's it gonna be? Gamer Jam, Drew Taylor. Wow. See, it's not broken. You know what's funny? It has been going in time order now, actually. Oh wow. Oh, this is kind of like, is this a probability question here? This is the most fair and just system I've ever seen. Yeah. Right? Okay. Of the 100 people who are watching a movie, 47 bought popcorn. No, 47 bought popcorn. Wait, what? Sorry, I'm having a stroke here reading this. 47 bought popcorn. Okay, more than 30 bought a drink. X bought both popcorn and a drink. And 2X bought neither. If X is greater than 0, what is the largest possible value of X? I like the idea of a Venn diagram, I do. Okay. So, what? This is like, there's like 100 people total. And then we got this, right? Some shit like this. And, okay, popcorn. This is drink. 47 bought popcorn. Okay. Not just popcorn, though. Okay. Good to see you, Jeff. Okay. So 47 is like the total that bought popcorn, I think. More than 30 bought a drink. Okay, so this is more than 30. X bought both popcorn and a drink. Okay, so this is X.
Nice.
And 2X bought neither. So 2X are outside here. Okay. If X is greater than 0, what is the largest possible value of X? Wow, thanks for all the follows, Gravity. Thank you, dude. Oh, and we got a shout out from Nerduino. Fuck yeah. What's up, Nerduino? Love that. He's a cool guy, Nerduino. Bum 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 bum. Okay. So 100 people total. Let's think about like what that has to encompass. So 100 people has to be equal to 2X. So that's people who didn't buy shit. And then let's see. This is also unknown, right? This is like Y. Like the amount of people that bought a drink is Y. We don't know that, right? We just know it's greater than 30. So 2X plus 47 plus Y and then minus X, because X double counts popcorn and drink buyers. So I think this is this is the first like kind of like solution or constraint, I guess, on the system. And then the other constraint here is that y is greater than 30, right? Okay. So I think what we want to do is we want to rearrange this for y, and then just plug that shit into here, and then we can get an expression for x, right? Does this make sense, Drew, Gamer Jam? Like how we wrote this, at least the first part. I don't think you have to brute force anything, actually. Okay, cool. All right. So 100 minus 47 is 53. And then 2x minus x is just x. Plus y. Okay. So 53 minus 2x is equal to y, I believe. Or, sorry, x, not 2x. Sorry. Yeah. 2x minus x is just 1x. Okay. Okay. So 53 minus x is equal to y. Now I can plug this into here. And so I get 53 minus x has to be greater than 30. Okay. So 53 minus 30 has to be less than x. So what is that? 23 then, yeah. X has to be less than 23. So I think the largest possible value of x is 22. 22. I guess we should plug that back in and make sure that makes sense, right? Let's consider that, right? Okay. If x equals 22 from this, right? Then y has to equal 31. And does that make sense with our situation here? So does 100 equal 2 times 22 plus 47 plus 31 minus 22? Well, probably. All right, one of these goes away. 47 plus 31 is 78. 78 plus 22 is 100. 100 equals 100. Yep, we're good. Nice. Great.
Bing bang.
Beautiful. We're on a roll today. So not too bad. Yeah, until I get to your question, Breasticles.
Yeah, it might be a little difficult. I was looking into the determinants just because I was curious, and I guess the way to think of it, right, is how it scales under a transformation, is because it's actually I guess determinant is also equal to the product of your eigenvalues.
Ooh, okay.
There's what, a couple of Google searches is telling me. Which I've never seen it that way, but
yeah, I know, right? If you're trying to figure out the eigenvalues of a 2x2, right? Right, it's a minus lambda, b, c, and then it's d minus lambda. And then what do? I think you do a minus lambda times d minus lambda minus bc has to equal to 0. This is how you find the eigenvalues, yeah?
I think that I want to say it's like lambda I or something like that.
I thought it was a minus lambda I is equal to 0, right? Isn't that what it is?
Oh,
Pretty sure.
yeah, determinant of a minus lambda.
Right,
so
and then
yeah,
this is a minus lambda
that's
I.
a minus lambda I.
Yeah. Okay, so then you get that. Oh, well, they solve this, I guess, is what they do.
Yeah, they would solve that for the eigenvalues.
Is this become like a nice quadratic? I'm just curious, actually. What is this? So this is AD plus lambda squared and then minus A lambda minus D lambda, right?
Yeah.
Minus BC equals 0. So what is that? Lambda squared plus A minus D lambda plus AD minus BC equals 0, yeah?
Yeah.
Uh-huh. And then is this like a fun quadratic? I don't know. X equals b squared minus 4x. Maybe this like AD minus BC thing kind of determines how many eigenvalues you can have, right? Because you can either have 2 eigenvalues, one degenerate one, or you could have 0, yeah?
Yeah, I believe so.
Yeah. Gladiator, did you see the video of McDonald's CEO eating McDonald's and faking liking it? Yeah. He called it the product. That's what he called it. He called it the product. I don't know. Some people really like McDonald's. I don't really like McDonald's. I think if I had to choose like a favorite fast food, probably Chick-fil-A. Chick-fil-A is pretty goated. Minus like the political stuff, but like food's fucking tasty. I've never had McDonald's. Everyone should experience McDonald's at least once in their life. Burger King? No, Burger King is trash.
They have really good tacos, I'll say.
What? Burger King has good tacos?
Yeah, I really like their tacos.
Oh man. Thanks for the follow, XX. I mean, I know like Jack in the Box has decently cheap tacos, right?
Yeah, I think they're like $1 or $1.50 or something like that.
Yeah. All right, let's see. Let's roll. See what pain I'm about to put myself in.
Let's go gambling!
Yeah. Where's my animation? Breskles, it already picked you. Where's my animation?
Yeah, it did.
Damn it. If I hit refresh, it's probably gonna like do it again. Oh wait, that's the admin cancel. That's the admin console. Actually, wait, what the fuck? Wait, did that just clear all my things?
That's what it looks like.
Oh my god. There it is. There it is. There it is. Okay, but then it just cleared everything.
Yeah,
Great.
if it's anything like what I'm seeing, it's gonna go to 0
Okay.
submissions on.
Okay. You know why? Okay, and this is my mistake. I refreshed the admin console, and if you do this, and
It
the last
refreshes
command was
everything.
clear, it clears everything. No. Don't worry, I have all your submissions at least. I still have all your submissions. Because I backed those up. Those get backed up. The queue disappeared, but don't worry. Here. I'll put them all back. Lucky Cat's like, I'm putting my back in right now. Where were they? I should put something. I need to put a safeguard on that so they can't just like clear them. Also, I'm getting rid of the. Yeah, no. I need to like not touch the admin console. Why is there gambling and everything? I don't know. Apparently, it's part of the gamification thing. People love gambling these days. Have you seen Kalshi? All right. Let me see. Breasticles was this one. Okay, and then let me put what the other ones are. Lucky Cat, you put yours in already. Okay. Crazy Run Fan, what was this one that you submitted, dude? What is this? They're gonna make university admissions based on the spinner wheel. That would be funny. One sec.
Sometimes it seems like that. I've seen some like pretty concerning people on college.
Like you're just like wondering like how did they get here?
Yeah, a couple of them. I remember this one chick who asked me for help with her math homework.
Yeah.
And I was like, the fact that you got like a high enough SAT score to graduate high school concerns me. Because
Surprise, motherfucker!
like she was sitting there and it was like basic algebra, not even like factoring quadratics, literally like linear inequalities. And I'd be like, okay, so now you subtract 5. Never seen someone start bawling their eyes out as I told them to subtract 5 on both sides until I had met her.
Oh dear.
And it was like, it concerns me that you can.
They had an
Struggle
article
that
about
much.
this at UCSD where I think 1 in 8 undergraduates at the college can't do like middle school math.
Yeah, it's concerning.
It's because of grade inflation, and also like we got rid of all the. I'm gonna write a LinkedIn article about this because I understand the SAT got taken out because it is financially prohibitive sometimes to do well at the SAT, because if you have enough money, you can pay for the right tutors, you can pay for the exam. Basically, you can
Yeah.
But it took away all accountability of like a bare minimum being in place for math aptitude is the issue.
Yeah, I'd agree.
Yeah.
I think the scariest part is she wants to be a teacher. It's like you
Oh,
can't
dear.
do elementary and middle
Oh,
school
dear.
math, and you want to teach people.
Yeah. Well, maybe she can be an English teacher at least or something. Doesn't need to know how to do math.
Something.
COVID pandemic, bad education. People don't focus on learning because it penalizes you if you don't get the grades in the first place. Yeah, exactly. No, I agree. There's a huge disconnect between like actually learning the material and just getting like gaming the test so that you have a nice score. Yeah. Yes. Third pounders were rejected by Americans because they thought quarter pounders were bigger. Yeah. They usually guess the SAT. Yes. Yeah. In certain countries, what they'll do is they'll pay students to go in and only memorize like 2 questions on the exam and then come out and then just write them down, and then they create like a test bank. Yeah. There are a lot of ways to game like standardized tests as well, which is kind of fucked. But you need something to set the standard. Otherwise, like Breskill's saying, you have students who can't like subtract 5 from both sides and like somehow they made it into college. So you have to have some sort of like bare minimum thing. Okay, hopefully the queue like got fixed. Let me check, make sure the queue got fixed. Okay. Is that all of them? Yeah. Okay. Oh, and we're doing breasticles right now. Okay, cool. Okay. Nice. Okay, cool. All right, let's see. I think that's all of them. If yours didn't get submitted, just resubmit it. It should be in there. The scores got reset, but now you all have an equal chance. Okay. All right, let's see what we got. I spent an hour to get these emotes. Those are some cool emotes, E-Raven. Okay, calculate the Fourier transforms of the following time signals. Ooh, okay. Is this kind of like Laplace transforms? Calculate the
Yeah,
following-
Fourier transform is just a special case of the Laplace transform.
Okay. So,
Because the Laplace transform has S as any complex number, and Fourier just has it as I.
okay, so let's see. So this one would be, what is it? Integral from negative infinity to infinity. And then it's 1 over t squared plus 1 e to the negative I omega t, right? dt. Or is it d? Yeah, it's dt, right?
I think you would do like omega or different variables since we're talking about frequency.
Well, I have a one sec. Hint: you may find 3.17, but don't forget Feynman's trick for differentiating integrals, and for C, keep. Okay, I gotta go. Let me go find the book for this. There's so many different parts to it. They're like, go here, go here, go here, go here. All right, let's see. What page is this on? This is C 7.8.
Yes.
Okay. Okay. Let's see. Wait, where is it? Okay, here we go. 7.8. Okay, here we go. Hint: you may find these. Ooh, can I like click on these and they'll go somewhere else?
I think
What
so.
happens? Oh, Feynman's favorite trick. Oh wait, well that's in here.
Yeah, I don't. I think it might
Wait, if
just be.
If I click on this,
Like,
what does it do? Oh, it
Yeah, it just
links
takes you there
out.
for some reason.
Wow, that's so annoying.
Bruh.
What? They don't have the thing linked correctly?
Apparently not.
That's dumb. Okay. Let me go find out what those things were. Okay. 3.1.7. 3.1.7. What is Feynman's favorite trick? Oh. Was this what we went over at some point? No. Oh, this is something completely different.
Yeah, I think that's just a formula.
This is just a formula. Oh, okay. Okay. And for B... okay. We'll get to Feynman's favorite trick. Let's just try to do this first one. And then I need to remember what a Fourier transform is. Equation-wise.
I'll send it in Discord.
Oh, this is it, right? No?
Yeah,
that's the... Yeah.
I don't think so. I just sent the picture from Wolfram.
Yeah, I see. Well, let's see for this one. I think they make... You can probably do it with sines and cosines. What level of math is this book? This is like college. Okay,
I think we just passed it.
Here it is. This is it, right? The Fourier transform of yes, that's what I said, right? It's g of t e to the negative I omega t dt. Yeah.
Yes.
Uh-huh. And then if we want to inverse transform it, that's d omega. Okay, cool.
Yeah, but I think it just wants us to do the
Yeah, just the regular one. Oh, okay.
just find the
Oh, so
transform
yeah, this is what
for
I had. I literally had this right. Okay. Okay, I'm not crazy.
And then and then just evaluate the integral, I guess.
Uh-huh. Fascinating. So I feel like I want to write maybe the Euler equation for like what cosine is.
Yeah, I think so.
Also, interestingly, so this goes from 0 to infinity, but this is negative infinity to infinity, which, oh man, I can't say that's symmetric yet. Well, let's think. Let me think. What's up, Dabsy? Love your stuff. Love popping in. Thanks, man, dude. Appreciate it. Appreciate you, Dabsy. Okay, let's... I need Euler's formula. I should know this one off the top of my head. There we go. This is what I want.
I think, but I always forget whether it's...
I always forget. It's this one. Right?
I
This one.
has... Yeah, I with the sign.
This is what we want. We want this. Okay. Because in this case, right, then e to the negative I omega t is going to be equal to cosine of negative omega t, right? And then plus I sine of a negative omega t, right?
Yes.
Okay. I think that's right. Okay, good. Yep. Okay, so now let's plug this in. So then I have negative infinity to infinity, 1 over t squared plus 1, and then we're going to split this into two different integrals, right? So my first integral is going to be cosine negative omega t, right? And then we're going to say plus integral from negative infinity to infinity of I sine negative omega t over t squared plus 1. And then, of course, dt. Right, and then there is something special here, right? Cosine of a negative, yep. So cosine is an even function, which means, so if you have like, this is cosine, for instance, right? Well, make it look a little bit nicer. So cosine of negative x is just equal to cosine of x.
Yep.
Right. So I can replace this. We can just get rid of the negative, just straight up, right? Okay,
Yeah.
now we have that.
And we can rewrite it from 0 to infinity as well.
Perfect. Yes, exactly.
By
And
2, so that
yes.
we meet that same.
so because this is symmetric, and this is also symmetric, right? I can now write this as twice the integral from 0 to infinity. So instead of going from here to here, I can say Let's just do 2 times from here to here, because it's the same
Yeah.
thing. Okay, cool. That's perfect, because that's going to be this one, which is beautiful. This one,
Well, you know that's going to be odd.
this is even,
Sine's an
exactly,
odd value
but this
function.
is odd. Yep. But sine is odd. Does the I matter? Maybe not, I guess, right?
Not for the integral, no.
No, right? Because I is a
as
constant. Yeah, I can just pull I out. Okay. So integrating an odd function over negative infinity to infinity, this all goes to 0.
Yeah.
Beautiful. Nice. Oh, very cool. Okay, so now, and then this is literally from this. Oh, that's really cool. So in that case, what is that? So x is equal to t, a equals omega, and b is equal to 1. Yeah. Okay. So then I have pi over 2 e to the negative omega. And that's it.
2's would cancel, though.
And then there's another 2. Yes. And then there's another
Yeah,
2
so you
that
just
cancels. So then you just get pi e to the negative omega. Nice. Okay, that one wasn't too bad. I think I can do another one.
Yeah, that was terrible.
This one. I wonder
Yeah, that
if
one looks fun.
Feynman's favorite trick, he said. What was Feynman's favorite trick? Was that where he takes the...
Yeah, differentiating under the integral.
He differentiates into the integral, right? Yeah. I gotta remember how that trick works.
It's a Leibniz integral rule. So whenever, right, if you take a derivative in terms of x and say your integral's in terms of y, the derivative goes inside as a partial derivative.
Mm-hmm. Okay. Let me see. I understand those words, but
Yeah, fair enough.
the words are cool, but let me see what the fuck this means again. Sorry. Okay, here we go. Okay. di alpha is the same as d alpha, df d alpha dx plus. Sorry, excuse me. What's going on here? You're a god. How long did you wait for that emoji, Raven? Let me see. We did one of your questions earlier. Yeah, here, Feynman's favorite trick. It's literally this whole chapter. Okay, but where is his favorite trick? Where's his actual trick?
Probably at the very beginning.
Oh, okay, maybe it was at the beginning of this chapter. Yeah, let's go find it. Oh, here we go. Feynman's favorite trick. Okay. If you have the integral here, okay, I don't want to see this form. I really don't. Oh, man, dude, my brain just shuts off when I see all this. I just don't want to. Like, what? Okay, wait. I is the integral. A is a function of alpha. B is a function of alpha. F is also a function of alpha. Then di d alpha.
Well, you would start with a like a function of x, and then you would insert alpha as a parameter.
Okay.
That way, when you take the partial derivative, that integral in terms of x becomes a lot easier to evaluate.
Okay. Okay. Oh, because the alpha will like do some shit to it when I take the derivative.
Yeah, that or you to get a
and then I have to say
equation that you can
plus f b alpha db d alpha minus f a alpha d d alpha. Okay, I think I see what you're saying. Okay. All right, here, let me put this down a little bit further. Let's just do that. All right. Okay, that's what I need to do. This is the cute little trick. This is that. Can you please explain to me how to do stoichiometry? I'm not understanding. I have a test tomorrow. Danny, if you have a question about stoichiometry stuff, find like an example stoichiometry question that you have and go to our website here, actualofficehours.com, and just drop the screenshot in, enter your username, and hit upload. And it'll get put into the queue here. And then we do a little like fun little spinner wheel to select questions we go through. So that's the best way for me to help you. All right. Let me see. Where was the other one? Okay, and then I want to know this.
Yeah, and I imagine on this one, instead of using alpha, we'd probably differentiate with respect to omega, since the Fourier transform is in terms of omega.
Right, okay, so I have negative infinity to infinity, t over t squared plus 1, and then it's e to the negative I omega t dt. And okay, so I'm going to do it with respect to omega, because when I take the derivative with respect to omega, oh, that's going to pull down another I omega, another it is what it's going to do, right?
Yeah.
Which would then cause this to be t squared. So then if I have t squared over t squared plus 1, is that an easy integral to do? Because that's the goal, right? The goal is for me to like do a derivative and then turn this into something that's an easier integral to do. I think
an easier integral or a differential equation.
Uh-huh. Or a differential equation. Because in my mind, this is actually not a bad integral, right? This is u sub. This part kind of sucks.
Yeah, that's u sub, but the e.
Yeah, the other part kind of blows. But okay, but I do know how to do the integral. I start thinking, does integration by parts work? What's up, Abdullah? Yeah, earlier, Abdullah, we did do that. We did even and odd arguments for this integral and this integral. The other way would be to... What if we broke it up into this already? Like, what if I broke it up into my cosine and sine? And then... the question is the integral from negative infinity to infinity of t cosine of t, is that equal to 0? I feel like it is. Because this part's even on both sides, but then this is odd. Yeah,
maybe. Let's see.
Yeah, I think so. I think that integral is odd. Is that integral is 0. So my gut instinct is to try to make an even and odd argument, and then do like integration by parts, maybe twice, with cosine to just hammer it out. Maybe there is an easier way. There might be an easier way with this Feynman trick you talk about. It's just, yeah, t squared over t squared plus 1 isn't an easier integral to deal with.
Wolfram says that the t cosine t dt does not converge.
From a negative infinity to infinity, it doesn't?
Yeah.
Ooh. Oh, that doesn't help me then, does it? Okay.
I guess not.
I guess not. Let me just think individually. Maybe this will like give me some insight. What the integral of t over t squared plus 1 is. Like, what is this? In my mind, u is equal to t squared plus 1. So then du is equal to 2t dt, right? So then this is now the integral of 1/2 du over u. So this is 1/2 ln of u. Right? That's what, I think this is what this turns into. Or 1/2 ln of t squared plus 1. Is that right, according to Wolfram? Breasticles, if we do t over t squared plus 1?
Let me check here. Integral of t over t squared.
Oh, okay, wait. I see why that might not help us, though.
Yeah, that's correct.
Yeah, so this is correct. The issue is that when we do integration by parts, right, it's always uv minus integral of v du, right? And this would end up being this. And taking the integral of ln is ugly.
Yeah, that would not be ideal.
What if you make the t over t squared plus 1 into trig? I think you're thinking if t is equal to tangent, and then I have 1 plus tangent squared, which is secant squared. Then tangent over secant squared is sine over cosine. Oh, that's just sine. Oh, that's actually kind of nice. Wait. Does that work as well? They're saying, what if you say let t equal to tangent of u, right? Then, oh, well, dt is equal to secant u tan u, right? Or secant squared u? Oh, I see why this is just going to become another ln thing, right? Because then you have integral of tangent u secant squared u du all over 1 plus tangent squared u. This becomes secant squared of u. Cancel, cancel. And then you have just the integral of tangent of u du. Which I don't know what the integral of tangent is. I think it's ln, though. I think that's what happens. Yeah. And I think you end up just getting this again. Yeah. Oh, okay. All right. I think we have to do Feynman's trick. I think I agree.
Yeah, I think looking at the kind of the steps the book's taking, they use Feynman's to get to that t f of t e to the I omega t dt is equal to I df d omega, and then they use some substitutions from our first part in
from here
that we already evaluated from our solution. Pi e to the negative omega.
Okay. 1 sec. So I need to get to cosine, is what we're saying? I need to get to cosine somehow, right?
They didn't even like plug in f of t in the first place. They just
oh, they didn't.
Yeah, they just straight up they wrote f of t and then they took the derivative, and then most of the work from there is on the I df d omega term rather than the actual integral itself.
df d omega. So wait, omega is there alpha?
Yeah, well, no, yeah. So when we say right, that Fourier transform is f of omega equals that whole integral.
Correct.
So when you take the derivative, it becomes df d omega.
Oh, okay. Wait. Okay. All right, I see what you're saying. F of omega is equal to this, right?
Mm-hmm.
And so then what you do is you take the derivative with respect to omega of each one. So then df d omega is equal to, and you can bring the derivative inside. So this is d omega t. Well, okay, but t doesn't depend on omega, right? So this is just t over t squared plus 1 d omega e to the negative I omega t dt, yeah?
Yep.
Okay. And then, yeah, derivative of this with respect to omega. Okay, so that's t over t squared plus 1. That's going to pull down a negative it, right? E to the negative I omega t dt. Okay. Oh. Ooh, okay. And then are we using Euler's formula to convert this into sines and cosines maybe?
I think what they try to say is that since we know that the transform of 1 over t plus 1 is pi e to the negative omega, then we know that the transform of t over t squared plus 1 is I times the derivative of pi e to the negative omega.
Oh, okay, wait. Okay. You're saying that, like, because f, which, wait, okay. Like, maybe g. This is a gamma function? I hope not. I don't think it is. All right. G of omega was negative infinity to infinity, and that was just 1 over t squared plus 1, right?
Yes.
Negative it e to the negative I omega t dt. This is
I don't think there was an it term.
Sorry, there wasn't that. Yeah, you're right. You're right. Yeah. So this was the first one we did in part A.
Yeah, and if you were to take the derivative of that with respect to omega, we'd get.
So then dg d omega was equal to, but then we already knew what the result of this was, right? The result of this was pi e to the negative omega.
Omega.
Okay, so then dg d omega is equal to is negative pi e to the negative omega, right?
Mm-hmm.
Okay, and okay, this one. So we're trying to, like, maybe compare what this looks like to this ish.
Yeah, kind of, but we would we'd also want to look at what the integrand is on dg d omega, right? Because when you take that derivative for the integrand, it pulls out that negative it. We can pull the negative I out front, and then integrand is going to be the exact same.
Oh, I see. Wait. Oh, they do it, like, by comparison.
Yeah, in essence, yeah, comparisons and, like, a substitution there.
So then, yeah, this would have pulled out negative it over t squared plus 1 e to the negative I omega t dt, right?
Yeah.
And I see that this and this are only different by a factor of t. Is that what we're saying?
Well, if we look at our original f that they give us, it's the same thing minus the negative I omega t.
Oh.
You see what I'm saying? If we make it so that
you're seeing here. This is basically this.
So dg omega
divided by negative I.
Left side, or make it so the right side. Yeah, make it so the right side looks exactly like her original integral. We can substitute whatever value we get for dg d omega into our as f for our df dw.
This is clever. I feel like I'm, like, running around in circles, but yeah, okay. I see. So dg d omega is equal to this, but is also equal to this. This looks almost exactly like this, but it only just has a factor of negative I out front. Can't I just pull the negative I out front?
Yeah, negative I is just a constant.
Yeah, so let's just pull that out front. Okay. So then I could just divide by negative I, right?
Which works out to just I.
So, okay. So wait, so dg d omega which is equal to, times 1 over negative I, which is equal to pi e to the negative omega over I, is also equal to t over t squared plus 1 e to the negative I omega t dt, but then this whole thing is also just equal to f omega. Okay, so then the answer is
And
this,
so-
right? So f omega
So,
is equal to negative pi I e to the negative omega. Yeah? I think that's it. We can double check, I guess, right?
yeah, that looks correct. The only, yeah, they do some weird stuff with like the frequency about
Did
adding
they
in
get the same answer? Is this it?
yeah, they multiplied by sine of omega.
What? Why is it being multiplied by sine?
They said
What? Why?
for omega greater than 0, the transform is negative I pi e to the negative omega, but when omega is less than 0, the
Oh,
transform becomes
I see.
I pi e to the omega.
Okay.
So they
It's like some domain thing that's happening.
but yeah, I don't,
Okay,
I
cool.
don't worry that much about
All right.
domain personally.
I'll say we got it right. I think it's cool. All right. I'm gonna work on some other questions, but this was really cool.
Yeah, it was fun.
Yeah, that was really fun. Thanks for showing this to me, Breasticles. I think I'm getting more comfortable with Fourier's trick.
You are welcome.
Yeah, that's super dope. Hell yeah. Okay. Let's mark that one. That was... I'm learning things today, too. All right. New posts. There we go. Rest calls. Office hours, physics. All right. Cool. Let's go see what the queue's at. 7 questions. Wow. Okay. Quite a lot. Okay. Let's spin the wheel. See who gets picked. There he goes.
Let's go gambling!
I love math.
While we were solving that, someone posted that on the submission.
It makes people cry.
Yeah,
Wow.
Security Brickles.
Security.
Yeah, that was,
Wait, and they just won with a 3.1% chance. Whose question was this? Oh.
that was
Oh man, dude. But this wasted such a good chance on their question getting picked, and it's just a meme cat. I mean, I guess that's pretty valid. Okay.
I'd call that a win in my books.
I call it a win. That is a win. That is a win. Okay, I'm gonna mark that one as done. All right, that means we get to choose another winner.
Pineapple.
That was you, Pineapple. I'm just testing the chance. Well, look, yeah, the 3% chance won. Isn't that crazy? All right, let's go. Let's go. Do it again.
Let's go gambling!
Test Brickles. Okay. Which one is Test Brickles?
I think that one's also a meme. I think it's also a meme.
Surprise, motherfucker!
Okay. That had a 20% chance at least. Okay, fine. All right. All right. All of your other chances are getting a lot better. All right, here we go. I'm gonna choose another winner.
It's all the Ickles that are winning.
Let's go gambling!
Dude, I have it hard coded.
Security
If your last
Brickles.
name ends in Ickles, you automatically get picked. All right, there we go. Lucky Cat.
Bing, 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 bang.
Match the graph to the function. Not too bad. We can do this. All right, let's see. Match the graph to its function. No more prickles. Okay. All right. First thing you want to do, you want to figure out where this intercept or this vertex is, right? So it looks like the vertex is here. So that's at 2, -9. So vertex 2, -9. And then I also like finding these things. These things are cool. The x-intercepts. And so that's going to be at 8, 0 and -4, 0. Okay, great. So here and here. All right. Usually things have this form. So y is equal to x, or it's like a times x minus h squared plus k, where the vertex is at h comma k. So since the vertex is at 2, -9, that tells me h equals 2, k equals -9. So we need x minus 2 to be inside here. Yeah, so it can't be this one. Can't be this one. This is x plus 2. We don't like that. Can't be this one either. That one's plus. So it's either that or that. Oh, and they kind of made this easy for us, right? Okay, because then if k is -9 and it's plus k, so then this one has to be choice D. Yes, nice. Nice. Hitman says, hey bro, I have my calculus derivatives unit test tomorrow. Uh-oh. Do you have any meaningful advice? Okay. Meaningful advice? I would say, well, it depends. So wait, is it like all derivatives? Do you have trig derivatives? Do you have like implicit derivatives? Or is it just basic derivatives? Because I would say the number one thing I think people always mess up on is the chain rule. So I would make sure to do a bunch of practice problems using the chain rule. Oh, just normal? Okay, cool. Yeah, advice would be make sure you're very familiar with the product rule, the quotient rule. The power rule is kind of simple. But the chain rule, I think the chain rule is what messes people up the most. And so maybe look at doing some questions that have multiple chain rules. Like 3 chain rules in a row. If you want kind of an example of one of those questions, I have them on my YouTube. I have one where I have like a cute little video on stuff. Where is it? Where is it? Go to shorts. Click here. Chain rule. Just type in chain rule. And then here's a complete guide on like how to use the chain rule. Try doing, I think I have it broken up into like 3 different parts. So like for instance, this is the first chain rule. This is the double chain rule. And then there's also like a triple chain rule question later. So, make sure you can do something like this. It's a lot of like, yeah, a lot of keeping track of stuff. Yeah. So yeah, if you want, I would like, can you take the derivative of sine cubed of 10x squared? This sometimes messes people up. So make sure you can do that. That's kind of the number one thing I think that screws people. Yeah. I'm trying to think if I have any other derivative ones. I don't think you're doing implicit yet. I have an Algebra 1 test on systems of equations and graphing. Any advice? Systems of equations? Usually linear, right? Make sure you remember the cases for when there are no solutions and when there are like infinite solutions. So for instance, if your 2 equations in your system of equations are parallel lines, then there's there's no solutions. If they're coincident, then there's infinite solutions. Those are useful things as well. Yeah. Remember how to graph lines. I know some students just forget how to graph lines. I never did the quotient. Yeah, you can use product rule and chain rule, yeah. Alright, let's see. That was pineapples. Let's mark that as done. And then, yeah, Pineapple, I'll check your other one real quick. Oh, make sure I got to give a coin to Breasticles. Oh, I did. Okay, good. All right, let's see. Which one was this? Match the graph to its function. You got B. Yeah, that seems fine. That one seems okay. Can you solve a JEE question?
Surprise, motherfucker.
No. We've kind of banned JEE questions. They're just incredibly time consuming. They're just no fun. All right, let's go see. Who else are we gonna help out today? All right. Here it is so far. What was the answer for the Fourier transform? Oh, so I posted it in our Discord. Sorry, it's back here. We got pi I e to the negative omega. Negative pi I e to the negative omega. If you want to see it, I always post the screenshots for everything here in our Discord. And then here's like the whole, just the work for everything we did on it if you want to go check it out. The link to our Discord is, again, on the same website people are submitting questions. Just click here on join our Discord. All right, let's go help out the next question. And let's go choose a winner.
Let's go gambling.
Davsy.
My man.
Nice. Okay, Davsy, what do you got for me? Ooh. Nice. Ooh, this is a work question. Haha. Yeah, these are tricky. Okay. All right. A water trough is in the shape of a half cylinder. You know what I'm going to do, actually? Here, I'm going to put this into Gemini just while we're doing it so I can check later that I'm doing it the right way. I think I can do this correctly, but I always like to have a little double check. I have an SAT tomorrow. Any tips from actual education? The mathematician. Yeah, we have a whole like series of videos on the SAT, right? If you go to again our YouTube, go to here, channel, search, type in SAT, and then here's a bunch of like speedrunning the SAT, key math equations for the SAT. Part 2, part 3. There's a bunch of like suggestion videos here on the SAT. Just go watch them. They're pretty good. Get good at Desmos. Okay. All right. How much work is required to pump the water out of the trough when it is full? Okay. I have to sleep 13 hours beforehand? No, you don't. Dude, what? 13 hours? Who goes to bed 13 hours? Okay.
I do.
You sleep for 13 hours, Breasticles? What the fuck? Excuse me?
Yeah, but I think it's kind of just because like I'm somewhat crippled, right? I got 2.
Oh yeah, you did get in a really bad car accident. I remember that.
Yeah, so like.
Okay, you get a pass.
Sleep, I'm like out, but I never used to sleep that much, and so I feel like it's just my body trying to recover.
How long ago was your car accident? I'm curious.
It was like end of September, so almost
okay,
like
that's pretty
5 or
recent.
6 months.
Oh yeah. Okay. I don't know if it's like, me, like, I broke up with my ex-girlfriend like 6 years ago. I'm like, oh, she still hurts me.
No, I mean that's kind of valid. That's valid. I just I don't blame you.
No, 6 years is like no. Yeah, 6 months. Yeah, you get a pass. Okay. Can you solve Taylor polynomials next? If you submit a question, we will do it. Okay. Work. Here's the key thing for work. Work in physics is equal to force times distance. Okay. And force is usually equal to the mass times the acceleration of an object times the distance. I'm going to show you like where it all comes from. So mass times acceleration. Spell acceleration wrong. Yeah, for sure. Yeah, inside the box. Yeah, good. Yeah, that's how I think about it. The box. The box. The box is the law, dude. Okay. And then mass is equal to density times volume. Acceleration. So, in order to lift a piece of water, a piece of mass out of a container, the acceleration or the force you need to apply to that needs to be equal to m times g. Because here's what happens. Gravity, so you can say like force of gravity, is equal to mg. It's always equal to the mass of the thing times g, which is the acceleration due to gravity, trying to pull it down. So you need to apply an upwards force. So this is like force up needs to also be equal to mg in order to just barely get this thing out. Of course, if you pull it out quicker, that takes more work, and that it's not necessary, because they say like how much work is required. They're saying like what's the minimum amount of work that you need to do? Like what's the least you gotta do? Okay. So really, yeah, instead of acceleration here, let me not confuse you. Let's just say that this is equal to gravity. Mass times gravity. That's the amount of force that's needed to pull something out. Okay. Alright. So we know that so far. We're good? So density times volume times g, and then times distance. Great. Okay. Now, here's the thing. Within this trough, which has a bunch of water in it, okay, the amount of distance I have to pull, for instance, like a section of the water changes based on where I am in the container. So, for instance, the water down here needs to move a bigger distance up and out versus the water up here. But, for instance, there's less water down here than there is up here, right? Because of how the shape is, there's a lot more water at the top than there is at the bottom. So, this is one of these cases where we need to use an integral, because I need to add up all the little pieces of water and then take a record of, okay, for this little piece of water, first of all, like how much of the water is down there, and then how much distance do I have to pull it out? And so, the way to do that is to imagine an infinite number of these small little boxes and write that as an integral. Okay, so the integral ends up looking something like this. So work is going to be equal to the integral. And so let's think of what we want to do. Let's think of like how we want to add these up. Let me think. Okay, I'm gonna write some things. We'll think about the bounds in a second here. Okay, so we're gonna have rho. So that's density, and we're gonna say times volume, and then times g, and then times distance, and then this is gonna need to be over like d something. We're gonna have to like d something is like all the little things that we're adding up. So first of all, I can pull density and gravity out because those things are constant. The density of water is the same everywhere in the trough. Gravity is the same everywhere. So I'm going to have rho g integral of volume times distance and then d something. Okay. All right. So let's consider some sort of like coordinate system that we're gonna work with. I'm gonna call, and do they tell me how big this thing is? Oh, actually, you know what I'm gonna do? I'm gonna do it just in terms of variables, because because then they're going to ask me like what happens if stuff doubles and stuff triples. So I'm going to say that down here, we're going to say this is like y equals 0. And then up here, yeah, it's not really a fluid force, but here, this is y is equal to r, okay? Because we know the radius of this trough is equal to r. Okay. So I'm going to go from here to here, and I'm going to add up all the little bits of water, and then I'm going to take a record of like how far up I need to move things. Okay. So we're going to start from 0 to r, and I'm going to do that in terms of dy. I'm going to go from y equals 0 up to y equals r. All right. Let's think about, for instance, let's say I'm at some position right here, okay? And I want to think about, okay, all of the water that is located at this height. Let's say all of the water that's located at this height. Let's just say like y is equal to a. All of that water has to move how much distance? Well, that water needs to move this much distance, which is equal to r minus a, which in this case is r minus whatever the y coordinate is, right? Because this right here, this is how far up we are at the water we're looking at. And then the distance it needs to move, well, if it was from the ground, it would have to move r, but it's already moved some little distance y, so the total distance it needs to move is only r minus y. Yeah. So this is now here. I'm just gonna say this is y equals like something, and then this is going to be the distance to move the water. Okay. So now this can be replaced with r minus y. But now we got to think about how much volume of water. So what volume of water is located when we're here? And notice the volume of water changes, right? When I'm up here, I have a lot more water, right? Because that part of the trough is a lot wider. So, looking at it this way, okay, you can imagine that at every different height, you have basically a sheet, a rectangular sheet of water that is all at that height. And that rectangular sheet has a length of 3. It's going to have a thickness equal to dy, right? And then it's going to have a width here, which is equal to this. Okay? So, interesting enough, right? The volume is actually going to be dy. So here, I should have moved this over. Yeah, we should do this here. Volume, distance times, yeah, let's not do that. Here, we're going to do this. We're going to say like distance times volume. But then volume is going to be a sheet which will be 3 meters long. Okay, so that's 3 meters long. Or that's the length. Let's call that length. Let's call it length. Let's see, that's going to be length. The thickness of that sheet of water is going to be dy, right? So this like minuscule difference here, that's equal to dy. And then now I need the width. Okay. And I think I want the width in terms of y. So now we have to consider what the width across this semicircle is based on what the y value is. And what I can do is I can pretend that this is the equation of a circle, which tells me that so this would be a circle centered at 0, r. So I'm going to say x minus 0 squared plus y minus r squared is equal to r squared, and that's just r squared. Okay, cool. So I have x squared plus y minus r. Okay, so this is y squared minus 2r plus r squared is equal to r squared. R squareds cancel. So I get x squared plus y squared is equal to 2r. Oh, this is actually really cool. Okay. So now I can rearrange this. Watch. So then I get x is equal to the square root of 2r minus y. It's actually plus or minus. Okay. So this right here tells me what the x coordinate on the circle is as a function of y, right? So notice when y is equal when y is equal to r, you get the square root. Oh, this should. Okay, one second. There's something's wrong here then. I need this to be not squared. Oh, this is. There you go. It's 2r minus y squared. Because, okay, watch. When y equals r, so when we're up here at this height, you get the square root of 2r minus r squared. Oh, I don't like that. Man. I need x to be equal to r then. One sec. What am I doing wrong here? X squared plus y minus r squared equal to r squared. X squared plus y squared. Oh, minus 2yr. Oh, I fucked up. That's why I fucked up. Sorry, this is 2yr plus r squared. Okay, that cancels. Got it. This is 2yr. Oh. Okay. Wait. Let's move this around, actually. I think I see what I want to do. Sorry. All right. X squared plus y minus r squared is equal to r squared. Let's rearrange for y. So you get y minus r squared is equal to r squared minus x squared. Y minus r is equal to the square root of r squared minus x squared. Oh, wait, no, I want x in terms of y. Sorry. X is equal to r squared minus y minus r squared. Square rooted. That's what I want. Okay, now this makes sense. Watch. Because when y equals r, I get x equals the square root of r squared, x equals r. And that makes sense, right? When I'm up here at y equals r, my outer edge of the circle should be x equals r. And also when y equals 0, then you get r squared minus r squared, and yes, x is equal to 0. Okay, so this checks out.
Good job.
Okay, great. Okay, so that's the x coordinate. That's what this is. That's how far this distance is. So the width is equal to 2x, which is equal to 2 square root of r squared minus y minus r squared. Which we can kind of simplify that, right? Let's simplify that. So that's 2, and that's r squared minus y squared plus 2yr minus r squared. I think so, right? R squared minus or plus 2yr. Yeah, okay, so this cancels. And so you get 2 square root of 2yr minus y squared. Nice. Okay. That's equal to the width. Kind of ugly, honestly. Okay, cool. So now, we can write our integral. So work equals rho g, 0 to r. Distance is now r minus y. Width was 2 square root of yr minus y squared times length, which is given, and then dy. That's it. That's the whole answer. It's kind of an ugly integral to do. What time did the stream start today, Davsy? It started 3 hours prior to when it ends, so 6 p.m.
If
Pacific.
you factor out a y, you can bring that r minus y term into the square root.
If I factor out a
you get
y.
r squared.
Oh, I see.
Yeah, and the square root. So then you would get a
Oh, I see what you're saying.
square root of y, square root of r minus y squared.
Okay. Wait, but there's a 2 on this, right? Still. So you're saying if I factor out a y here, I get 2 square root of y, 2r minus y? Does that help me?
Yeah, I was looking at the one right below it.
Oh, right here. Oh,
Yeah,
I fucked up.
yeah,
I fucked up. I didn't put a 2 on it.
Oh.
Yeah. Oops. It would have been nice. That would have been nice, Breasticles, yeah. Dude, I don't remember this question being this ugly. This is a really ugly integral to do, right? Well, I guess you see some constants on it, right? L comes out, so you get rho GL. Integral from 0 to r minus y. And we can also pull the 2 out. And then it's 2yr minus y squared to the 1/2 dy. Let's see. What does Gemini do? Yeah, Gemini does the same thing. R squared minus r minus y squared. Yeah, see, here it is. Yeah. To simplify, so it does the u sub of let u equal r minus y. Interesting. And it starts, I think it starts the top of the trough at y equals 0. And then it says the bottom's at y equals r. Oh man, it's such a mess, dude. I guess I could have left the y minus r here, because then I would have had a y minus r here as well. And then maybe you get let me think. Also, did they put a 2 on theirs? And radius was 0.25, yeah. Okay, Dabsy, yeah. This is how you do it. I mean, it kind of sucks. But then plug in. But I think the thing you notice here, right? If length is doubled, length is on the outside, so that just doubles. And then when you do the integral for this, you end up getting something as r to the 3rd. And then that shows that the work goes up by a cubic when you do it. Yeah. Yeah. I wanted to do it for the general case. I think if I just plugged in numbers, this probably would have looked a little nicer. Also, interestingly enough, they defined this as 0, and then this as, like, I guess negative r. Anyways, okay, cool. Yeah, good question, Davsy. It's fun. I should do a video on this one. like at least explaining the concepts. Doing the actual calculus is kind of messy.
Well done! Well done!
All right, cool. What a fun one, though. All right. Davsy. Okay, let's see what's next on the queue. Let's choose a winner.
Let's go gambling!
Nice. Adjutant, it's you. Let's see what you gave me.
Wheel does not like crazy at all.
Poor Crazy. Yeah, Crazy had a
He's been
50%
driving for
chance.
like 2 days.
Adjutant says finally. Yes, thank you for waiting, dude. I know. Okay, let's see. I think this is asking questions about wavelength, it looks like. Wavelength and speed. And periods. Frequency. Okay. I see like 60 hertz, 6,000 hertz. What are they trying to probably figure out here? I think they're just trying to compare the wavelengths of two waves. Let's see if ChatGPT can like understand this. I'm actually kind of curious. If ChatGPT can translate. This is Bosnian. Yes, I know 343 technically. Here, translate this. Let's see if ChatGPT can translate your handwriting.
I think the speed of sound is the only value in physics that I don't know it in SI, but I know it like exactly in feet per second.
What is it exactly in feet per second?
I don't know if it's exactly, but it's 1100
Oh, okay.
at least at sea level.
I'm seeing if we can translate this. ChatGPT is having a hard time. Okay, I think what Adjutant is asking about is if I have two waves at different frequencies, what's the difference in their wavelengths? Because then I see like lambda 1 f1 is lambda f. Or maybe what's the ratio of them, maybe? Okay. Well, I mean, here's the basic thing. So frequency times wavelength is equal to wave speed, which I call V. This gets a little weird, though, because sometimes they'll write frequency as V.
Disqualified.
But let's just do it this way. Okay, so this is frequency. And then this is wavelength. And then this is the speed of the wave.
Yeah,
And
it looks
yes.
like that's the same notation he uses as well.
Right. Right. And so for sound, it actually depends on the temperature. Technically depends on temperature. On temp. But the common one you'll see is either 343 meters per second. Yes, I can definitely help you with balancing equation. And that's at 20 degrees. Recipe, if you want to get help, just submit a screenshot of what equation you need help with balancing, and we'll do it. Just there's a website there, actualofficehours.com. But 330 meters per second, I guess, is kind of like easier. Right. Oh, I see here. Oh, here it translated the Bosnian, Serbian, Croatian. It said find the frequency of a wave whose period is 3.12 seconds. Okay, here we go. Okay, here we go. Yeah, let's do this. All right, we got it. Bless ChatGPT. So 343 is technically at 20 degrees centigrade, or easier would be 330. Which is a good question. Is it 330 if it's warmer or if it's colder than 20 degrees centigrade? I want to say the speed of sound increases with temperature, right?
Yes.
Because the
'cause
particles move
you-
faster.
Yeah, I was asking ChatGPT just to figure out
Yes,
what it
speed
would
of sound
be, and it's,
is proportional to the absolute value. Okay, yeah. Actually, interestingly enough, it oh, that's in water. Okay.
Yeah, so it says the equation for V, right, when you're talking about like the actual wave equation, right, you get your phi of t squared
Density.
and then your v squared, phi of x squared. That term v for your wave speed is equal to the square root of your heat capacity ratio times pressure divided by your density. And pressure
And then
is your
yes.
density times R times T, which gets you
Right.
V to be square root of your heat capacity times RT.
Yeah, that's where it comes in. Yeah, I remember something like that because there's like density of the air and stuff. Okay, cool. So, if we know the frequency, if we know the period is 3.12 seconds, and we want to figure out the wavelength, so to find out the wavelength, that's gonna be equal to V over F. So that's gonna be speed over the frequency. But actually, the cool thing here is we know, so that's like the same thing as V times 1 over F. 1 over F is also just the period. So it turns out this is actually just equal to this times the period. So if you want to make this easy here, you can just type in, oh, well, cool, I know what the speed is. It's 330. And then the period in this case is 3.12. So you can just do a little bit of math. Where's my calculator? Calculator. There it is. Okay, yeah, so 330 times 3.12. And that gets you 1029.6 meters. Wow. 1,000 meters. That's a lot.
yeah.
Approximately. Okay, cool. Oh wait, sorry. They didn't want the wavelength. They wanted the frequency. Sorry, they wanted the frequency of the wave. Oh, all right. Well, okay. So that's just 1 divided by 3.12. Okay. So 0.32 hertz. So actually, yeah, let's not do this. This is not what we wanted. Okay. So 3.12 equals 1 over F. F equals 1 over 3.12. And that equals 0.321 hertz. That's the units for that. And then the wavelength of sound frequencies are 60. Okay, so then wavelength is equal to V over F. So that's going to be 330 over 60. And then the other one is 330 over 6,000. Okay, so then 330 over 60. That's equal to 5.5 meters. And then this one's divided by another 1,000. So, or another 100, I guess, right? 60 to 100. So that's going to be 0.055 meters. Cool. Not too hard. I think that's what you had anyways, right? Oh, I see. ChatGPT read it as 6,000 hertz, but I think you put 5,000. Okay. That's okay. Nice. Okay, cool. Good question, Adjutant.
Well done! Well done!
Yeah, you're welcome, dude. You understand a bit better? Good. That's that's a goal. If it ever doesn't make sense, I know it's really late for you. I know it's like 5 o'clock in the morning for you right now. You got to go to school soon. But we have other people that stream at more appropriate hours for Bosnia. If you ever want to figure out when they stream, again, website's here. Click on the streaming schedule, and that has the calendar for everyone that streams. Oh, cool. All right, let's see what's next on the queue. Danny, did you give us a stoichiometry question to go through yet, Danny? I see a couple here. Also, Recipe, just to show you guys how this works. So once you upload your question here, it gets put on this queue. If you ever want to like boost your chances of getting picked, you can click this upvote button every 3 minutes, and it will boost the chance that your question gets picked. All right, cool. All right, let's go choose a winner.
Let's go gambling!
Who's it gonna be? Who's it gonna be? Crazy Run Fan. There you go, Crazy Run Fan. Finally. You had a 47% chance of winning. Okay. What is this mess? What is this mess?
He's trying to do the integral from of 1 over x to the 5th plus 1.
1 over x to the... Wait, what? Sorry, what?
1 over x to the 5th plus 1. Now, I have a cheat code that I would recommend you, because right now that's a really like shitty integral to solve.
Wait, this is the integral he's trying to solve?
Yeah.
Okay.
It would be really easy if it was on a definite boundary rather than a indefinite boundary. But right now, the way he has it decomposed, right, the two right integrals, you can't decompose it more into partial fractions with like your basic ordinary methods. So I would back up, and you can factor them all into linear terms if you take the complex roots. You're gonna have five complex roots by the fundamental theorem of algebra.
I see.
And then those are gonna be a lot easier to, because you're all just gonna get natural logarithm terms. There's gonna be imaginary components.
I see. This is the same thing. This is gonna be the same thing as the integral of 1 over it's gonna be like x minus r1, right? X minus r2, x minus r3, r4, r5, right?
Yeah, and I mean they're going to be all, most of them are all going to have complex values, right? But they're going to be a lot easier to evaluate.
This is almost like complex analysis, no?
Yeah, that is complex analysis. It's called Jeff said the 5th roots of unity.
Yeah, because I'm going to say x
like
to the 5th plus 1 is equal to 0, right? This is what I'm trying to solve for, I think, right?
Yeah.
So x to the 5th is equal to -1. And then I think what I do with this is x is equal to e to the...
Could be, the easiest way I do it is if you just
2
draw
pi
the
I
unit
over
circle.
5? Is it this?
Yeah, something like that, and then you add some stuff. The way I do it is if you draw the unit circle, right?
Yeah.
You're gonna have one that's gonna be -1, right? And that we just know off rip that -1 is gonna be one of the solutions to that, and then you just rotate around the circle, right? In fifths.
Okay, so if I need -1 to happen, I need this to happen, right? It has to. My whole thing needs to go around this way, right?
Yeah, and then you'll just rotate around the circle in fifths.
Oh, okay.
And each one of those will be roots, and you can just figure out the exact value of those roots, right? Because your complex coordinate system is going to be a plus bi, and then those roots are just your x and y is just the same as it would be on your normal unit circle.
Okay, I think I'm understanding this. So if this is like, okay, it's in fifths to get to there, right? Like it's like
Around
1,
the
2,
entire
3.
circle.
It's around the whole circle?
Yeah, it's around the whole circle.
Why is it around the whole circle? The
It just is.
way I see it, well, let me just think here, right? So I can represent this, right, as e to the I theta, right?
Mhm.
And so e to the I theta to the 5th needs to be equal to e to the pi I. Is kind of what we're saying, right?
I believe so.
Because this is -1. Degrees are for degrees, people. Right, okay. So e to the I theta to the 5th, that's e to the 5 I theta is equal to e to the pi I. So then what is this? 5 theta equals pi? 5th roots of it's the 5th roots of unity, not the 5th roots of -1.
Yeah,
Wait,
it goes around the whole circle, and you have the complex conjugates as well. So you have to evaluate the full circle. So you just do 72 degrees across each one. You just separate the entire circle into fifths.
You want e to the 2i pi? What's up, Mean Machine Rex?
Bing, bing, bang.
Nice.
Okay. I'm just trying to understand, like, because I know in complex analysis we do this. I'm just trying to remember. If only there was a way to remember that. Okay, so this is equal to e to the 2 pi I. Sure. I wanted it to equal -1. Y'all saying it should just go equal 1. Why can't I just have it equal -1 though? I want to have it. Isn't that the whole point? The whole point's for this.
Yeah, we're taking the 5th root of -1, and if you just go in fifths of the circle,
yeah,
each one of those, when you raise that to the power of 5, is going to result in -1.
Okay. 5th root of unity is 1 to the 1/5. All right. I'm gonna trust you guys here. Okay, so 5 over 2 theta. Okay, so 2 pi over 5. And yeah, that's equal to 72 degrees, I guess. Is that what we said? Right, because 1/5. Wait, what? Pretend you're slicing your pizza into fifths, starting with the negative x-axis. Okay, I like that. I just want to intuitively understand this. But you start at 0. You start at 36, not at 0. Okay. 1 second. Okay. This I understand. I want this. I want to slice my pizza this way. Yes. Yeah, we finally got. Well, I don't know how I fixed it, but it did fix. Okay. And then you're saying I want 5 more slices of pizza. So
yes.
1, 2, something like this maybe. 1, 2, 3. Did we make 5 slices? I think we made 5 slices. 5 slices.
Yeah, it looks like 5.
Okay. Someone's getting more pizza than the other person. My eyes. I'm sorry. I don't know how to slice the pizza. It's something
I'm pretty sure
like
that
this.
right. That's on the right. I think that's a 90-degree angle there. That looks like 90 degrees.
Oh, okay. All right. He says 36 and plus 36 are 2 the angles. We can do that at least. Let's make that happy. There you go. That's one of them for sure. And then this is the other one. Okay. And then we're saying 72 are the next couple ones, so 72 would be like 108. Which would be like, oh, okay, 72. Does that look better, Zach? We cool with this? It's well, I actually have like a degree thing. It'll actually tell me what the degrees are. So apparently this is correct. Okay. I see. That's better. Okay, great. Okay. Because, all right, if this gets raised to the 5th power, that's a vibe coded 36 degrees.
You just put that image in for.
Okay, here. Let's make people happy. All right, thank you. Let's make them happy. There you go. There you go. There you go. Is that better? That's better, right? Okay. That still doesn't look like right. Okay.
It's more accurate.
Okay. So then my roots are whatever here, 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 and here. So there's definitely one real root, right? There's x equals -1.
Yeah.
Okay, that's cool. All right, so I have x plus 1 is one of the roots, right?
Mm-hmm.
And then I have oh fuck me, whatever these fucking angles are, dude. In the plane.
Well, and you can just solve those like normal trig. You will do it on the unit circle. So that would be.
So is this 72 degrees, right? This is 72. So then this must be 18 degrees. Does that seem right? Guess so. No, 36. What am I saying? Wait, but that doesn't... Oh, it doesn't need to add up to 90. Thank you. Yep, got it. Okay, and then this is 72 degrees. Okay. Yep, thank you. All right, Breskles is doing the Lord's work here because I just don't want to figure these out. Cool. Uh-huh. Ew. Those are all gross as fuck, though. What?
Yeah, you could just write them as those e to the 3
e to the pi I over 5, e to the 3 pi over 5, e to the I pi, e to the -3, e to the -1. Okay. Okay. So that's what this has turned into, though, right?
Yeah, and then from there you can just do a partial fraction
fractions
decomposition. But at least when you do that, you're just gonna get like a bunch of arctangent terms, or not arctangent, natural log terms that you can evaluate rather than
Okay.
whatever the hell that is.
Okay, so I'm gonna write down the first one I like, which is
polynomials and shit.
there's x minus 1 at least, right? And then there's e to the pi I
should be x plus 1.
correct. Pi I over 5 e to the 3 pi I over 5 e to the negative pi I over 5 e to the negative 3 pi I over 5. I don't think I want to do partial fractions here. Fnatic says, is there really no nicer way than that? Perhaps there is some closed form for 1 over x to the n plus 1 in general. Breasticles? No, Breasticles is just a really smart college student, right? You're a junior, right?
I'm a
undergrad? Sophomore, yeah. He's really fucking smart sophomore. Someone says you sound like you have a PhD. Congrats.
I do not.
Not yet.
I don't know if I'd go for a PhD.
I agree. Don't do it. No.
I feel like it'll result in me just teaching, which I don't want to end up like, you know, I have this one teacher, he taught me DiffEq.
Yeah.
And he'll like talk about like, yeah, I basically just for fun wrote like an entire thesis, you know, on the heat equation. I just never published it. And then he stuck teaching like Calc 1 to a bunch of miserable engineering students who don't want to be there.
Yeah.
You know, that's I don't know. I wouldn't spend that much time to do that.
I know. It definitely takes believe me, I had the stage that you're having at your life of where like Man, there's a whole PhD comic on this. What is it? Oh man, it's so good. Is it PhD comics? Stages of PhD? Yes. Oh man, what was it? It was XKCD. Might have been XKCD as well. Yes, this is it. This is kind of like before grad school, you're like, I'm gonna research whatever I want, and then when you're a grad student, I'm gonna research whatever my professor wants, and then assistant professor, I'm gonna research whatever my committee wants, whatever the grant committee wants. I'm gonna research whatever, and then you're just fucking dead.
Yeah, pretty much.
Yes,
The masters, I will go for a master's. So
masters is useful for sure in engineering, at least for sure. I definitely had in my early grad school days dreams of I want to like change the world, figure out fusion, blah 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 blah, and then you go through it and you realize it's all bullshit.
Oh shit, not good.
oh, I don't have those dreams. I just want to get paid.
You just want to get paid, yeah, sure, for sure. Yeah, and
Pretty much,
teachers
yeah.
don't really get paid. They don't. No, yeah, teachers don't get paid that much.
No.
No, it's unfortunate. But things can change, you know. In life, you start realizing, I don't know, maybe you marry like a sugar mama cougar or something, dude. Like,
Who knows?
then you don't care about getting
That would
paid.
be a good life, yeah.
Yeah, it'd be a good life. Then you can teach. You can do whatever the fuck you want, dude. Yeah. Recipe says, "Are you a teacher?" I am a teacher. Well, I mean, I do many things. I teach at UCLA occasionally, and right now I work for like a tech startup as well. So I get paid and I teach. So both things work. All right. I don't know if I actually want to fucking do this, so I'm just gonna say do partial fractions and then integrate. Are we cool with that?
Yeah.
Okay, cool. Nice.
That's dope.
Yeah. Cool, Crazy Run. That was cool. If you have a cooler way to do it, I invite you to please post it in our Discord. Would love to see it. Yeah. It is
Just
fast.
Put bounds on it. Bounds would have made it so easy.
Yeah, if we had, yeah, because we could have at least like
'Cause you could just
done
use
something
residues.
definitive. Oh, residue. See, yeah, that's would have been cool.
Yeah,
I would
that's
have liked
when that's when residue theorems pop in, because each one of those roots is technically a residue, and so if it was bounded, you could say that whatever, we don't give a shit what's in the integram.
Yeah.
We know it's equal to the sum of the residues.
Wait, what? Dude, TikTok like has the weirdest restrictions on my account. I just got a notification. Gifting is suspended because the behavior is not in line with our policies. Reason: inorganic gift solicitation. Dude, what? What's my inorganic gift solicitation, TikTok? I'm just saying teachers don't get paid. TikTok has the funniest, like, dude, I don't know what, like, they're doing over there in China analyzing my text and, like, thinking what I'm saying. Like, what? I don't even think I said anything. Yeah, they say I'm soliciting for gifts in the wrong way. I didn't even show my feet. Oh, wait, I did talk about sugar moms and cougars. Oh, maybe that's it.
I don't see how
Maybe-
that relates to like gift solicitation though.
Yeah, what? Yeah, what? Go after all the fucking thirst traps, dude. Chill. I'm just trying to teach math. Okay, Crazy Run said, what I was hoping to do is I could get help converting those integrals into arctangent. Ooh. I don't think they convert into arctangent. I think they turn into a bunch of ln's. That's what they do. Yeah, because you're going to have like x minus something. Then it's just ln of that thing. That's all it is. They turn into arctangents? Okay. I will leave that to the other math experts. ln's of 8 and arctangents? Yeah. Let me see. They do become arctangents? Okay. If one of you awesome people in my chat wants to go through and do that, that'd be great. Let me see who I can help in the last, like, 13 minutes here. Okay. There we go. That's apparently it. That's the Mathematica answer. That looks messy.
Yeah.
I don't want to do that. It's just brutal. Tuma says, no, I need help. Okay, Tuma, I'm going to help you. Well, I mean, if you get picked. So, here, we got to go to the wheel. Let's go to the wheel. 4 left. Let's go gambling.
Let's go gambling.
Who's it gonna be? Who's it gonna be? It's gonna be SW. What did you submit, SW? Ooh, SW submitted a physics question. All right, let's see if we can do this. Maybe I'll stream later. Like, maybe I don't technically have to do anything after this, so maybe I'll help you guys. I'll stick around. Okay. The crate has a mass of 80 kilograms and is being towed by a chain which is always directed at 20 degrees from the horizontal. Determine the crate's acceleration in 2 seconds if the coefficient of static friction is minus 0.4 and kinetic is that. And the towing force is P equals 90 T squared, where T is in seconds.
I looked at the Mathematica steps or the Wolfram steps for that partial fraction decomposition for
Yeah.
the
Is it a mess?
arctangents. It's 34 steps just to do the
Surprise, motherfucker.
decomposition.
Yeah, we're not doing that today. What do we say to the Lord of Death? Not today. Okay. All right. This is at a 20-degree angle. That's cool. So that means we're gonna have components of the force. So we're gonna have Fy is gonna be equal to let's just say like F sine 20 degrees, and then Fx is going to equal to F cosine of 20 degrees. Cool. Fascinating. The force is a function of T. Oh, then F is equal to 90 T squared. So the force starts at 0.
Disqualified.
Wow. Okay. So we gotta figure out some other forces. So there's the force of gravity, which is going to be 80 G. And then there's the normal force, which, interestingly enough, okay, so for the sum of the forces in the y direction, you need Fn plus F sine 20 degrees to be equal to 80 G. Otherwise, this thing would, like, fly off the map. Yes, exactly. The key thing here is there's also a force of friction. Yes, friction. Very good, guys.
Good job.
Here, let me... Let me extend the calendar for you guys. Extend it. Dun, 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 dun. Okay, there you go. Another 30 minutes. All right. All right. So, yeah, this thing won't even start moving until Fx beats out F friction. So, sum of forces in the x direction. No one can explain why friction doesn't increase with speed. It's a big physics scam. Oh, man. Okay. Sum of forces in the x direction, that's going to be equal to F cosine of 20 degrees minus F friction, which, when stuck, equals Fn times 0.4, because that's coefficient of static friction. Okay, so, yeah. This thing doesn't start moving until you have enough force pulling it to beat out, this is called, like, friction max. I call it, like, Fs max. And that's equal to that. But yes, the upwards force, right, so pulling on it at an angle does reduce the normal force. Yeah, so this is where things get, this is really topsy-turvy. Okay, so from this, Fn is equal to 80G minus F sine 20 degrees. And then F, we know is equal to 90T squared. So 80 times 9.8 minus 90 t squared sine of 20 degrees. Okay, that's Fn. Let's figure out the time when it first breaks free. So that happens, so like first breaks free. First breaks free when f cosine of 20 degrees equals Fn times 0.4, because this right here is what I call like Fs max. Okay. So we got to plug things in. So I get 90 t squared cosine of 20 degrees is equal to 0.4 times all of this. Yes, the acceleration goes from 0 to non-zero instantly. Yes, correct. There is a discontinuity. Okay, this is ugly to solve. I'm just gonna use a calculator. Because I got like a bunch of shit going on. I just don't want to deal with it. Alright, here we go.
Just when you say small angle approximation, even if it's not.
Yeah, but it doesn't work with cosine.
Disqualified.
Problem.
That doesn't matter.
We're just gonna call it 1.
It's a physics question.
I
They
know.
don't care if you get the math
I don't
wrong.
care. It's gotta be just close enough. Alright, 90. Okay, then
Yeah,
this is
exactly.
0.4, 80 times 9.8. This is the OG way of solving algebra. Just fucking graph it.
That's usually how I do it. That's how I used to always check my my max and mins on calc.
Yeah, I mean it
So I
works.
just
Right?
throw it in Desmos and take a
Just
look.
graph it. See, does that thing even cross? Oh dear. Well, that's not good. wait, let's make sure we did this right. Oh, yeah, no, I'm in degree mode. That's fine. Okay, wait. 90x squared cosine 20 is 0.4. I don't know where. Okay, is 0.4. 80 times 9.8 minus 90x squared sine of
Didn't
20.
your 9.8 be a negative?
No. Because the normal force is equal to mg.
Oh, normal force. Yeah, no. Okay, I see.
Yeah.
I was thinking that was gravity.
Yeah. That's equal. It's equal. Yeah, it's equal to mg. Oh, I see.
Yeah.
It does intersect. It's just way up there. So we gotta like. Okay. First of all, we only deal with positive time. The maximum of time we're ever gonna look at is 2 seconds, right? And then here 0. We can make y max like 100. Let's just see. There we go. Okay, so that's that. So that's the force. That's the t squared thing. And then this should cross at some point. Oh, it doesn't though. Right? 90 t squared cosine of 20 degrees. Yeah. Does it never beat friction then? Yeah, I don't think you have enough force at t equals 2 then. I think it just sits there. That's kind of silly. Let's extend it out. Let's say to like 10 seconds. There you go. Yep, there it is. There's the friction. Oh, wait, it does. It intersects at 1.799. Oh, I needed my Y thing to be taller. Sorry. All right. 2 2 seconds, and then y max we need to have like at like 300. Okay, there you go. Now it'll graph correctly. There we go. There it is. There's the intersection. Okay. So we can say it breaks free at t is equal to 1.8 seconds.
Good job.
Cool. All right, that's when it breaks free. So, now once it's broken free, all that changes is now friction. This coefficient drops. Okay. So, and what are we trying to figure out? The acceleration, right? Okay. So, after 1 point, this is, you just have to double check this just to make sure it even like broke friction. So after it is moving, and there is kinetic friction. Okay, so then you have the sum of the forces in the x direction, which is equal to the mass times the acceleration. So which is equal to ma, which is equal to 80a. And then that's going to equal f cosine 20 degrees. So that's going to be 90 t squared cosine of 20 degrees minus the force of friction. But the friction is now going to be 0.3. Wait, at some point this thing will leave the ground because the angular force is increasing? Yeah, I guess it will. You're right, Jeff. Yeah, eventually it will leave the ground. It has liftoff eventually. Okay. Okay. This is what the equation is. Okay. So A is equal to 90 over 80 and then all this. Or no, sorry. It's equal to 9/8 t squared cosine 20 degrees minus 0.3 over 80. All that. Here, let me get the screenshot of this one too. Yes. Yeah, exactly. Sorry, let me fix this. This is what I wanted to show. Okay, so then you just plug in 2. Plug in 2. Calculators can graph. The ones made by the military industrial complex can. Okay. Alright, so now you can just put this in as a math thing. So what is that? 9 over 8 times 4 times the cosine of 20 minus 0.3 over 80 times 80 times 9.8 minus 90 times 4 times the sine of 20. Cool. 1.75. Alright, so A is equal to 1.75 meters per second squared. Nice. Alright, that was SW's question.
Well done! Well done!
Baby voice, did baby voice turn on? There's another one for that one, SW, on question 4 you have. That one looks cool as well. We can do that one another time, if you want. I hope that helped you out, though. Are you able to do one that takes 2 minutes? We'll see if it gets picked. I put an extra 26, extra 30 minutes on the clock, so I will get to
Most of them probably. There's only 3 left, right? Only 3 here on the wheel. So let's go spin.
Let's go gambling!
Who's it gonna be? Who's it gonna be? You have a good chance, Rezipe. Looks like it's you. Congrats. You had a 37% chance, and you got it. Congratulations. Ooh, we're gonna balance some chemical equations. Love it. Let's do it. Yes, thanks for playing. Okay, here we go. All right, let's balance. Tuma's like, bruh. Tuma, make sure you upvote. If you upvote, you get better chances. Okay, let's see. I always like to balance the most complicated thing first here. Fascinating. Where this is kind of complicated is, yes, we have NO3 present, but one of the things that makes up NO3, the oxygen, is unfortunately also present here. And it's also present here. So you can't like treat NO3 as its own little thing. All right, so we have Cu, H, N, and O. Cu, H, N, and O. Anything by itself, I usually balance last. I'm going to balance copper last. Oh, very cool, Rezipe. I'm glad you found us on YouTube Shorts. Yeah, it's like a long-term tree I plant because people keep always researching stuff and then they find us. I'm glad you made it to the streams here. Okay, so let's see. I think I want to try to balance. Oh, man, this is tricky because nitrogen's also present everywhere. I think we just have to kind of shoot something and see what happens. Okay, I'm going to go with nitrogen. I'm going to try to balance nitrogen. Let's just put a 2 here. Let's put a 2 here on the nitrogen. Okay. So that means I have 2 nitrogens here because... Well, actually, no, I need more than a 2, sorry. So let's count how many nitrogens on the right here. So N2, so that's 2 from there. And then that's another one here, so that's 3. Okay, so I have 3 nitrogens to start. So then, in order to have 3 nitrogens here, I'm going to put a 3. We're going to assume everything is 1 for now, right? Okay, 3 nitrogens. We have see you next Tuesday. Okay, no, we don't want to do too much crazy math. Okay, let's look at the... Okay, I can't really change anything else at this point, right? The nitrogens have been fixed. Nitrogens are fixed here. Let's check what the other stuff works out to be. Let's check the oxygens, okay? So here I have 6 oxygens, 8 oxygens, 9. Ooh, that actually works out pretty nicely, right? Right? 6, 8, 9. Here I have 9 as well. Love that. Okay, I fear the hydrogens are going to screw me, though. And they do. Okay, because watch what happens here. H doesn't work. Yep, because I have 2 hydrogens here, but 3 here. Damn, and there's no way to change the hydrogens without also changing the oxygens. This is a very tough one to do. Just double it. Yeah, we could try doubling it. Okay. Yeah, so we hit a dead end because... Well, okay, actually, the issue is I don't want to put any number in front of this because even if I put a 3/2, then that affects the oxygen. And I already had oxygen balance, which is really nice. Okay, so that tells me this is not going to work. So we're going to have to probably do something a little bit higher. All right, let's bump this up to 4 maybe. I think that's probably the next thing to do. Let's bump it up to 4. See what we get. And then let's maybe try to balance the hydrogens first. So this gives me 12 oxygens. Okay. And actually, no. Let's not balance the oxygens yet. Let me just balance the hydrogens. Okay. 4 hydrogens means I would need 2 over here. Some of this is kind of like trial and error. You try to balance different things first and see if it works out. And then let's see what we got for nitrogens. So right now I have 4 nitrogens. How can I get 4 nitrogens here? Well, I have 2 here. So I would need another 2 here. Right? Because that would give me 2 nitrogens here, 2 nitrogens here. So now we got 4 and 4. I'm happy.
Good job.
Let's cross our fingers that oxygens work. So here I got 12 oxygens. Let's see what we got. I got 4 oxygens here. I got 2 oxygens here. That's 6. I got another 6 oxygens here. That gives me 12. Bingo bango, baby. Oh, that's so nice. Okay, cool. So then we just slap a 1 on this so that we have 1 copper. And we have 1 copper. And then it's good. 999 says, what's the timer? Timer's how much longer I'm going to stream. So it's how much longer I have to answer questions. Okay. Someone should create one that doesn't have a solution.
Surprise, motherfucker.
This is honestly the hardest chemistry balancing question I've seen. Because there wasn't anything intuitive to kind of like pick where to start. No, I didn't like this one either. Honestly, this is kind of a tricky one, to be honest. Because my usual strat of like pick the most complicated thing and balance that first didn't really work. But that's okay. Chemistry always has exceptions. So, yeah, you do still have time, Tuma. So, yeah. In this case, if you run into a dead end, notice how like I think I tried to balance the nitrogens first, and then that didn't work out. So then I was like, okay, let's go balance the hydrogens first. And then I was able to see, oh, if I balance the hydrogens first, then it's not too bad to balance the nitrogens, and then that somehow makes the oxygens balance. And then again, whatever is by itself, that is last. Always balance that thing last. We really need to form a Troll Dr. Gold nonprofit. Love you guys. Okay, cool. All right, I hope that makes sense, Recipe. That was a really fun one. I'm gonna post the solution to this.
We already do have a Troll Dr. Gold. It's whatever question I submit when I join stream.
Yes. Yeah. Although yours weren't that bad today, Resticles. They weren't that bad.
Hey, I can change that. I got worse ones.
No. Be nice. Be nice.
Surprise,
Don't
motherfucker.
do it, dude. Don't be nice. I like the niceness. Oh man. But yes, ResPay, awesome. I'm glad you found us. Again, anytime I do one of these questions, they get put into our Discord. So here will be like the YouTube link to the recording for the stream and where we do it. And then there's the question, and then here is the screenshot of what the solution was. Actual miseducation. What is breast? What is this, dude?
That was the other one that I was thinking of submitting. A different book. And that's
like
on. It's on applied partial differential equation.
Okay, yeah, but I don't know PDEs.
You're not that guy. You're not that guy.
Well, some of them are like the second one. isn't too bad. I don't think you need actual PDEs to do it, but a couple of them you definitely do.
Nice. Resbay, you just joined? Cool. Resbay, what's your name on Discord? Because you get points for asking questions, and I want to give you like a point for asking that question. And then once you get like 10 points, we buy you gift cards and stuff. So it's fun. But yeah, if you see your question, just it's there. Just react to it or like say something in it. It's in the Homework Help channel. Really cool channel. Yeah, awesome. Love it. All right, let's see. Let's go to this one. Let's see. Let's go choose a winner.
Let's go gambling!
Do you think it's gonna be Tuma? Tuma, you have a really good shot here. Yeah, and it's you. Congrats, Tuma. Thank you for waiting 67 minutes.
That's dope.
Wow. What's up, brother? We're doing fluids?
Yeah. I really thought it wasn't gonna be me.
What did you had a 74.4% chance of winning.
I have
hope it was
really
you.
bad luck, bro.
I know. I feel that sometimes. Okay. The fluid force in newtons on a vertical plate submerged in water where the dimensions are given and the weight density is that. Oh, okay. Fluid force. How do you do this one?
Let me see if I can find the.
I know the fluid like acts like this and it also acts like this and like it does this and it does this. Yeah, I can remember how this works. No.
The depth and the width.
It's the depth and the width. Yeah, this is what happens. Sorry. As you go down, the force gets bigger like this. Oh, interesting. But wait a minute. Because this is a symmetric object, aren't the forces going to cancel? Forces cancel.
What does that mean? What like? It
Thanks, Jeff.
zero?
We'll see you. Yeah, here we go. One sec. I'm just saying. Well, I'm just saying because on each side, right? So here it says, yes, for a vertical plate. So if you have like a single plate down, and like there's fluid here, but there's not fluid here, right? The force is equal to the integral of pressure times dA, which that's density. Okay, so yeah, so that's equal to rho dW dy as you go down. Wait, isn't the depth equal to y?
Yeah. I think there's two integrals to this because there's also a bottom half. Depends where you place it on the graph.
On the vertical place where the dimensions are given and the weight density of water is 9,800.
I was told to place it on like the centroid on like 0, 0.
Oh, like right here? Call this like 0,
Yeah.
0?
Pretty much, yeah.
Okay.
That's what Gemini told me.
And then figure out see, yeah, my question here though is like the fluid is exerting force symmetrically because this is a symmetric object. Usually when let me find an example question. Yeah, this is usually what happens. But is it? Yeah. So isn't the net force equal to 0 then? Well, oh, sorry. There is a net force upwards. Oh, and that's the buoyancy then. Yeah. One sec. Yeah. This is kind of where's actually. Let me go to hyperphysics. Hyperphysics is great. Yeah. Yes. Aren't we gonna draw little DA rectangles and integrate? Probably. I thought I remember that cancels out on the left and the right. Yeah, this is the other one you kind of see. Uh-huh. Right. So, for instance, if this was like submerged, you have the force of the fluid that's acting to the right, and that increases as you go further and further down.
Right.
But then on the right side, technically air is another fluid, and that force acts on the left. But for air, the force doesn't really depend on the depth so much. It's just the atmospheric pressure, because the density of air is so low. So if I have something that's, again, dropped down, but is symmetric, I would imagine that all of the forces that are pushing this way end up canceling all the forces of the fluid that are pushing this way. The only difference is you're going to have more force pushing at the bottom than you will at the top. So you end up getting like a net force that pushes this thing up, technically.
Like a boat.
Yes, and that's what buoyancy comes from. That's why things are buoyant.
But if this was like a square, it would be different.
I don't even think you want to do this.
No?
No, I think this is called, is this Archimedes' principle? Yeah. Yeah, the net force acting on an object is equal to the volume of fluid that is displaced by the object.
Oh, I think I saw something similar to that. Like,
yeah,
ChatGPT like made it like really easy for me.
Yeah, this is super easy. Yeah, this is super easy. This is just Archimedes' principle. Okay. The reason for this is the entire thing is submerged and surrounded by fluid. Yeah. If it's not completely submerged and surrounded by fluid, so for instance in this case, right, only like part of it is submerged.
Yeah.
Then there is a net force to the right acting on this object. But when something is completely submerged, the fluid on the left and the right cancels each other out.
What?
Yes. Yeah.
But I remember when I solved those kinds of problems, like, does it have to be like a diamond kinda? Because like I remember I was solving like squares.
It's just anything. It's anything, any object that is submerged. The forces to the left and the right cancel, and the only difference is the up down, and then that is just equal to the volume of the water, the volume of the fluid that's being displaced. I'm pretty sure about that. Like here, look at this fucking fishing thing. You know, where is this? It's not gonna be 0. The net force is not 0 because it has to kind of like float up.
Oh.
Yeah. Let me. Sorry. Yeah. You know what we can do actually? Here, we can start like questioning ChatGPT, and I'm gonna have it prove that it's right. Yeah, I don't think you don't even need to do the row depth thing, Pen, because the interesting thing is, all right, and this is also, buoyancy does not depend on how deep the thing is, because as you go further down, you have more fluid on top pushing it down, but you also have stronger forces acting at the bottom that push it up, and so it's and because it's linear, right? It's rho gh, right? Rho gh is basically force. Because this is linear with height, they cancel.
That's so weird. That's why boats are like shaped like that.
Yeah, boats are shaped just to like occupy. Well, okay. The boat thing, I think, has to also do with stability. Yeah, this, for instance, is not a very stable thing. If this was like if there was something like trying to float out of the water here, this would not be very stable.
Wouldn't the bottom part be a little flat? That's why it's more stable.
Yes. Usually you want things to be more flat because you don't want like this. You don't want this unstable equilibrium of two forces. So, for instance, if you have, yeah, like a ball. Well, no, a ball is not very good either. What? No.
You done messed up, Aaron!
I think you literally just want. This is what you. This is what you want. You want this.
Oh.
Because literally, it's in order for something to tip. In order for something to tip, this is a cool thing called tipping point. You need the center of gravity of the object to exceed the what is it? The rotation point. Yeah. So here, this is tipping point physics. Yeah. This is it. Okay. Yeah. Where's a nice little... There we go. Okay, so here's like kind of a cool little graph of it. So, center of gravity right here is here in the blue, okay? So, gravity always acts on the center of gravity of an object, and it acts straight down.
Yeah.
If I start trying to push this thing to the right, okay? Do you see how like that pivot point would be here on the right side of it? Okay, so at figure B, the center of gravity still pushes to the left of the pivot point, which means gravity is still trying to push it back to being stable.
Yeah.
But once you tilt it enough so that the center of gravity is past the rotation point or the pivot point, now gravity helps to cause this thing to get knocked over.
This makes sense. Yeah, I've done this before.
Yeah, so it's all about when you have something and you're trying to design it not to tip, you want the center of gravity and the pivot point, for instance, to be very far from each other. Because then now this takes a lot of rotation in order for it to tip completely. Because any slight modification to it, like for instance being like slightly up this way, gravity still wants to restore it back.
True.
Yeah. If your boat is like this, okay, this is actually really shitty, right? Because your rotation point is right here. So the second this thing moves at all to the right, the whole thing is just gonna tip.
Yeah, the waves are gonna push it.
Do you think we have time to balance an equation? Yeah, submit it. I'll do it. Okay, anyways. Yeah, so I think for this one, you literally just use Archimedes' principle, which is just rho GV is equal to F net. That's the net fluid force. So in this case, it would be equal to 81 times and is it a cube? It's a vertical plate. Dimensions are given meters. Yeah, but wait, how thick is the cube? It's just a plate?
Like the diagonal?
Yeah. I mean, how deep is it?
It's 3 plus 9 square root 2, right? Over 2? No, over, yeah. Just like Pythagorean's theorem. If you took like half the...
No. I know what you're saying. You're saying that this depth here is 9 root 2.
Yeah. Over 2.
9 root 2 over 2? Is it 9 root 2 over 2?
Yeah.
Yes. Yeah, okay. Yeah, but why do the boats have... I mean, the boats usually have pretty flat bottoms, honestly. At some point. That's a good question. Yeah, you're asking like why are they like keeled and stuff. Sheesh, I get 4,822 1744.44 is my integral.
Oh hell.
Oh hell no.
That's actually I tried it before. I think that's pretty accurate.
What is this, dude? What? But now I want, I need the thick, because see how they give you a density here? Density is newtons per cubic meter. This, I only have the area of, that's only in square meters.
Oh, the density actually, like, isn't that 9,810?
Yeah. But I need that times a
per-
volume. I need that times a volume in order for there to be like a net buoyant force on it. But so yes, I know this is a 9x9 like square, but I don't know how thick it is.
Like, well, I'm still not sure what you mean.
Like, how high does it come out of the paper?
Oh.
Yeah, you need a volume. Do you see how this only gives you an area?
Yeah,
I need a volume.
but I don't think it's like a 3D.
Yeah. Well, everything has to be 3D eventually in the world, right? Nothing can be
Yeah.
completely flat.
True.
Assume a spherical cow? No, dude, no. Okay. Man. Let me see. Pressure on a plate submerged. Pressure on a submerged plate. I'm just curious about this.
And seconds.
Oh, does it say 10 seconds? No, it's okay. I'll finish this one. Submerged plate. Oh, okay. What class is this for, dude? What is this for?
Calc 2.
That's weird.
It's my fault for taking an online class.
Yeah.
I could have asked my professor.
You said this was Calc 2?
Yeah.
It's a really physics-heavy question for
Yeah, it's a
Calc
very
2.
physics-heavy question. Yeah. I mean,
even my friend didn't understand it.
I mean, it's just like all physics mostly. I feel like.
sine theta.
I mean, I'm taking physics, but it's like algebra based, which is dumb.
Because I feel like the forces cancel. The fuck?
I don't know. I showed this to AFG and he solved it in like 2 minutes.
Oh, okay.
But I didn't understand what he was saying. I think I have the work right here. I think. Yeah, I have the work.
Yes, send it to me. Let me see it.
He didn't want to do solve the integral, but he still like did the work. Because the integral is easy.
Let's see.
This
Five
was for a
root-
different problem, by the way. Hold on, let me send you it was like 5 instead of 9. See?
Wait, it's the same. That's the same question.
Yeah, but the difference is it's 5 instead of 9.
It's 5 instead
Like-
of 9. Where's there 9? I don't see
Yeah.
the 9s in here.
Like
Where are the
replace
nines?
No, like if you look on my question, you know how like it says 9?
Does your question say 9?
Like the sides.
Oh, okay. Yeah. I got you.
Yeah, just replace them with 5.
Ooh, yeah. Center, bottom, okay, sure. Row, okay, from 3 to that. And then what's this 2y minus y minus 3? Where's the 2y minus y minus 3 coming from?
He was using the depth width thing. Maybe I should get him on here.
Oh. No, I see what he's doing.
Oh yeah.
Okay. I get it. I get what he's doing. Okay. Alright. Let me erase all this. Alright, so I think width he's saying is this. This is the width. And so when you're going, and okay, so and this distance here is going down 3. And then you're going from 3 to whatever
5
this
squared 2 over 2.
No, 9 squared root of 2 over 2, right?
Oh yeah, true.
Right? And then you go down another 9 squared root of 2 over 2. Okay.
Plus 3, right?
Eventually, yeah. I'm just saying that like the distance from here to here is this,
Oh,
distance
yeah,
from
yeah.
here to here, this distance from here, this is this. Okay. So then the force, so you have 2 different areas because as you go down here, the width gets bigger, but as you go from here to here, the width gets smaller. So the first thing is going to be going from 3 to 3 plus 9 root 2 over 2. What's up, Gladiator? All right, and then that's just going to be the 9800. And then the depth, well, that's just going to be y. We're going from y equals 3 to y equals 3 plus 9 root 2 over 2. And then the width is
Wait, how can you go from 3 to 3 plus 9 over? Isn't it like the other way around?
No, it's okay. You're going from small number to bigger number.
Oh, okay.
Yeah, this is just bounds. This is okay. It's because I know things are like below, but they're calling like positive. They're calling below like positive. Like as you go further down, your depth is increasing.
What the heck?
Yeah. I know like technically y is positive here, y is 0 here, and it looks like y is going down, but they're redefining this is like y equals 0, like up here. And then this would be y is equal to, whatever. I mean, the bottom down here is y equals 3 plus 9 root 2.
Oh,
Okay, the coordinate system is just flipped.
that's weird. I don't like that.
Yeah, I don't like it either. It's so
Okay.
funny. The net force on this thing is just going to be the buoyancy, but whatever. Okay. So, density, depth is y. That's how far down you are. And then width. So, the width refers to this, and this is where you have to do a little bit of geometry, right? So, the width starts at 0, and then it goes up eventually to having a width of 9 root 2. Right? The depth is... Oh, sorry. The depth is 3 plus y. Yeah, my bad. Yeah, sorry. Wait, no, pen? Wait, no. I started my integral at 3. I think I'm okay. Yeah. I think if I start my depth... Yeah, I'm calling this y equals 0. So then, yeah. You're right. If I start in... Well, let's see. How did Tuma do it? Yeah, Tuma also started it at 3 and went to that.
AFG.
Yeah. Or AFG, sorry.
Yeah.
You're Tuma. Okay. Right. Okay. So then, yeah. So the width, this is like similar triangles. I gotta think. Because now it's like flipped. Ugh. Yeah. Let's do like ratios. This is where things are gonna get funny. Okay. So this to this needs to be equal to like whatever this is to whatever this is. So 9 root 2 over 2 divided by 9 root 2. What's up, Zach? Have some nice dreams there, Zach. Thanks for stopping by, dude.
Isn't there like an easier way to solve this?
No, there's not. Yeah, because the width changes as you go down, and so what we're doing, I'm doing a ratio. So I'm saying the total height of like this triangle over the total width is going to equal to like what the partial height would be, which in that case that would be. So you got to remember, if this is y, then the partial height is y minus 3. So it's y minus 3 over, and then this is the width. Do you see that?
Sorry.
Okay. So, green triangle, right? I have height over width. Height is 9 root 2 over 2. Width is 9 root 2. Okay, that's the ratio of two sides, right?
Yeah. 1/2,
and then what?
Right? 1/2 of that.
Well, no. The width is the whole thing. So then, and then what I say is, okay, let's pretend that I'm only this far down. What would be the height of this triangle? Well, the height of this triangle would be whatever my y distance is down, subtracted from 3. That's what this is. So that's y minus 3. And then the width, which is what I'm looking for, is just w.
Oh.
So in this case, yeah, and this is the variable I want. So w, and let's see, this cancels with this. So w equals y minus 3 all over 2. Or no, sorry. W equals 2y minus 3. Which I think is also what AFG had. Yeah, he has 2y minus 3. Yeah. So that goes into here. So this is 2y minus 3. And then that's dy. But that's only finding that's only finding the force for the top half of the triangle. And then you have to go for the bottom half of the triangle. So the bottom half
is the depth is 2y minus 3 and the width.
No. The depth is y. 2y minus 3 is the width at depth y.
Okay.
Okay.
Yeah.
And this is all for the top half of the square. Now to go for the bottom half of the square. Okay. I'm going to go from y is equal to 3 plus 9 root 2 over 2 all the way down to 3 plus 9 root 2. Right? Because this whole thing here, right, is 9 root 2.
Yeah.
Okay. And that's the same thing. 9,800. The depth is y. And then what's the width? Okay. Well, the width starts out as being very wide, and then it goes down to eventually being 0. So, now we got to kind of rearrange. We got to think about the bottom triangle, which it's going to be, it's very similar, like, in shape. So, this, again, is 9 root 2 over 2. So, I can say, okay, cool. So, 9 root 2 over 2 divided by 9 root 2. That's the full triangle. And then if I'm only some distance here, okay, now my partial triangle is going to be this whole distance minus whatever y is, because y always measures from from the top of from the surface down to wherever I'm measuring the pressure. So now my inscribed triangle has a height equal to 9 root 2 plus 3 minus y, and that's all over the width.
Okay.
Does that sound convincing, or does it sound like bullshit?
It sounds like it makes sense to you, but it doesn't make sense to me.
Yeah, okay. All right. Okay.
This is what ChatGPT gave me. Like, I don't know. This looks like easier, kinda. I don't know how it got this answer.
They're not doing the integral. Yeah. There's a simplification if you just take the centroid and then you just multiply it. Yeah, sure. By the depth, that you also get the same answer. That should be 9 root 2 over 2 though.
Oh yeah.
Yeah, they're just saying that F equals rho GH. Where this is distance from surface to centroid. Okay. The distance from the surface to the centroid is, so h in that case is equal to 3 plus 9 root 2 over 2. Right? And then they're just multiplying that by, by the density. So they're doing, actually, sorry. So they're doing density area H. So they're saying 3 plus 9 root 2 over 2 times the area, which is 81, times rho. And then you're done.
Bruh. And it's right?
Yeah, I guess that's right.
Man, I have like no energy. I spent like 2 weeks studying for this midterm.
Whatever, yeah, you can just memorize this. I mean, this technically works. This is a cooler way to do it. I agree, it kind of looks like it sucks. Yeah, whatever.
That's the way I want to do it. Because it would make more sense.
Yeah. It's 9 root 2 plus 3 minus y. But then this is all over 2. Which I think is probably what AFG had as well. Yeah, look at this. Yeah, 3 plus 5 root 2 minus y. See how I have 3 plus 9 root 2 minus y over 2? I understand what he's doing. This works. It sucks.
Wait, can I get that?
It's an absolutely like awful integral to do.
Yeah.
Yeah, I'll send it to you. Don't worry, I'll send it to you. But just to like try to like understand, right? This is just like doing inscribed triangles.
Inscribed triangles.
It's inscribed triangles, right? What inscribed triangles tell you is, for instance, so if you have two triangles inside you, there are two wolves. But if you have like two inscribed triangles like this, okay? The ratio of their sides is the same. So what you say is you say like height over width has to equal height over width.
Oh, yeah.
Okay? And that's what I'm doing here, is I'm saying, okay, for the first one, which is, this is the big triangle, the height is 9 root 2 over 2. The width is 9 root 2. That's the big triangle. But then I need to figure out, oh, okay, well, what about the inscribed triangle? The inscribed triangle has a width W, and that's the thing I need for my integral. I need what the width is as I go down of that triangle. So what's the height of this triangle, right? What's the height?
It's 9 squared 2 over 2.
It's not. because the height of this triangle changes as I go down, right?
Oh yeah.
See how it could be here, then it could be here, then it could be here?
Yeah.
You have to think about, in terms of y, what is the height of this triangle? Well, y points from here all the way to here, right? That is y. But the height of the triangle is only this portion. Okay? This portion is equal to the whole depth, which is 3 plus 9 root 2. Right? Look, 3 plus 9 root 2 minus whatever y is. Whatever y is, so wherever you are, that subtracted from 3 plus 9 root 2 gets you the leftover height of the inscribed triangle you're dealing with.
It's 3 minus y?
It's 9 root 2 plus 3 minus y. Yeah. This isn't even physics. This is Calc 2. It's super annoying. Okay. I'll save this for you, though. Okay? Take a look at it.
Okay, thank you.
You're welcome.
Dr. Gold, the goat.
That's dope.
Oh, man. No, I get it. It's super confusing. Yeah, and honestly, like, I didn't get it at first either. So, bless AFG for, like, kind of showing. I get it now. It's just...
Yeah.
It's one of
I
those
hope this is
dumb
not
things.
on my exam.
Yeah, that would suck. Maybe just memorize the shortcut.
Yeah.
If it's on your exam, report your teacher to like the board for like cruelty. Or not even the board, maybe like the Supreme Court. I feel like that's
Supreme
what you
Court,
say,
dude.
bro. Yeah, I feel like that's like cruel.
Yeah,
and
dude, true.
You want to know what's even more cruel? He added an extra chapter at the end of the midterm without even us like studying the homework.
Disqualified.
Yeah,
They do
checks
that.
out.
He just feels bad, dude. He's just like, oh no. All right. I really want to go, but Nick, sorry, did you have another one you submitted? You said there was an equation one. What's this? I don't know if I can do Taylor series right now. Yeah. No. This for another time. I could do this another time, Taylor series. Teachers are the worst.
Disqualified.
Penn is a
Let's ruin
teacher.
a solution for Crazy's problem.
Oh man. This isn't too bad. This is exponential stuff. First order rate. Mexi? Where's you? Mexi questions? Okay. These are all so fun. Man, you guys have so many questions, but I do have to like go. Ami, which one? Ami, which one was yours, by the way? Ami. This
I
is
think
what?
the
I can't do all these.
that
There's so
was-
many of these. Lucky Cat. Oh, okay. One sec. Lucky Cat. Oh, that's your PC account. Oh, so you have like two different ones. Wait, isn't your name usually Pineapple? What? Why is your name Lucky?
Yeah.
What? Okay. All right. When this is divided by x minus 1, the remainder is 4. Find the value of k. Show your process algebraically. Oh, this just means f of 1 has to equal 4. Right? Isn't that what this means? Yeah, right? Because
no,
the root...
if it's divided, it's you do like the synthetic or
No.
long division.
Dude, this is the remainder theorem. This is the remainder theorem. Okay.
Oh,
'cause
it is divided by. I thought it
It's
has
divided
to
by
be
x minus 1. So
divided.
the root is 1. And so, yeah. Yeah, you're good, Tuma. So, I think this just means f of 1 is equal to 4. So, the right two cancel. You get 1. K equals 3. Yeah, I agree.
Yeah.
What's up, Penn? I'm correct. Penn said it's correct. Okay, I will do one balancing equation just for you, Nick, and then I do have to go. I'm already pretty over time. Pick the hardest one, he says.
You done messed up, Aaron!
All right, I'll pick this one. This one looks kind of hard. I wonder if TikTok's still banning me for speech or whatever. Okay. Let's see. We got C's, we got H's, we got O's. C-H-O. Because O2 is by itself, balance it last. Balance the most complicated thing. Most complicated thing is carbon. So I'm going to put a 4 on this. I got 4 carbons. I got 4 carbons. Alright. I'm going to balance oxygens last. Let's balance hydrogens. I have 8 hydrogens. How do I get 8 hydrogens? I put a 4 on this. Now I got 8. Now I got 8. I got a TikTok warning for soliciting gifts, is what they said. I don't even know what that means. 8 plus 4 is 12. Okay, here's the beautiful thing, right? Now I just need to bounce this. Oh, man, we got odd numbers. Damn. Okay, fine. Whatever. Alright, so I have 1 oxygen from here, which means I want 11 from here. So the way to do that would be to call this 11 halves. Right? Because you see how 11 halves times 2 would get me the 11, and then plus 1? That would be great. We love that.
My man.
So I can't have fractions. So yes. So then you just take everything. See, because now things are at 12. Great. Now you just multiply everything by 2. And that'll get you 2, 11, 8, 8. And now you're all good. That look like a pi over 2 coefficient? Yeah, it's missing. It's missing the little hat here. Little hat. That's a combustion reaction. Because it's oxygen plus hydrocarbons equals CO2 and water. Yes, I can definitely post that for you. Yeah, which one was that? Mexi, number 2. Cool. And there's table. Can you check? Help me. What's the table? Who is Pineapple? Pineapple. Pineapple is Ami, which is apparently their PC account, but is also something else. Yes. You're welcome, Max. Cool question. All right. I really gotta go. So let's close out the stream.
That's dope.
All right, thank you everyone for coming to Actual Education Office Hours today. I really appreciate it. We had a lot of fun questions. I learned a lot of stuff. I learned about more Fourier transforms, Feynman's tricks. I learned about how to figure out pressure for 2D objects in a Calc 2 class.
Disqualified.
I learned that I can't solicit gifts on TikTok by talking about, I don't know, what was it? Acquiring sugar mamas so that you could teach? Apparently they don't like that word.
I think so.
They don't like that word.
I guess not.
I guess not. Okay, anyways. If we did get to your question, do not worry. We will post these all in the Discord for you. So, I know we had quite a few actually. Mathematician, what was yours? Taylor series. I would like to do these. Taylor polynomials are cool. It just takes me a lot of time. I can go do these tomorrow because we do have a stream tomorrow. Yeah, right, Pen? So if you click here on streaming schedule, you can see the calendar. So, actually, sorry, we don't have a stream tomorrow. My bad. Thursday we have a stream. Come on by Thursday. Thursday we will have a stream where we can help out with those. But anything you submitted gets put in the Discord, and if it doesn't get solved, the bot will solve it, or someone else will solve it. So, love. But yeah, make sure go check out all the other awesome people who are streaming. Zach's on tomorrow, and Penn Center as well. Both in my stream. Let me shout out you, Penn. I don't think I gave Penn Center a shout out today. I know I gave Zach one. You can go learn about Riemann surfaces. More homework help starting next week. Yes. I will need that because next week I'm gonna have to remove all these streams. I'm gonna be in Japan. So stay on top of all the cool stuff and awesome streamers we have. And again, if you're watching us on TikTok or YouTube, make sure to go join the Discord here. And you can also go watch us on Twitch. It's nicer. And let's go raid someone on Twitch. Konnichiwa. Yeah. Arigato gozaimasu. Let's see who are we gonna go raid. Who's doing some let's see, who do we got? I keep acquiring more and more friends on Twitch. I love this. This is great. Horse Girl plays horse games. I don't know about that. Oh, Syzygy. I like Syzygy. Syzygy's cool. They're a physics person. The Cuneiform stream. Wow, I don't even know what this is. But I think that sounds academic. So go check them out. They're cool. Okay, cool. All right. Enjoy the rest of your Tuesday. We will see you on Thursday. Peace.